Okay, very good morning, everyone. Welcome to another HSMA training day, and the third and final of the kind of Python fundamentals session. So these are I hesitate to say it's your Python training because your Python training continues well, at least for the next 6 months, and I would argue beyond that into your coding careers, because we're always all of us learning new things about Python. But certainly the three sessions that we've been running over the last few weeks are there really to teach you some of the basic fundamental building blocks of Python. Certainly not exhaustive, but some of the key things that you're going to need moving forward, both in the course and in terms of what you'll need moving forward for your project work if you're doing some data science. So in the first week, we talked a lot about some of the sort of basic elementary building blocks of Python, things like conditional logic, loops, inputs and outputs, how to handle variables, that kind of thing. And then last week, we introduced you to functions, a really important aspect of any programming language. And we talked about functions as well as exception handling, how we sort of more neatly deal with potentially user input errors, for example, or some sort of input error. And we also talked about file reading and writing, how we deal with that, which will be very useful when you come on to do modeling work. And then, of course, in the afternoon, we talked about NumPy and Pandas, which are two hugely important libraries for data science. So this week, in the kind of third and final of the Python primers, we're going to be focusing a lot on object-oriented programming. So going back to that concept that we talked about back in the principles of programming session, and showing you how you can build object-oriented code in Python. Object-oriented programming can take a little bit to get your head around, but once you do, because it kind of needs a different way of thinking. Once you do, though, and give it time to sort of sink in, but once it does, you'll find that it's actually a really nice way to think about structuring your code, and it's very elegant. And certainly for some of the upcoming training, you'll get to use object-oriented code much more. So if you don't quite get it today, or you get basically try and get the gist of it today. I think that's the key thing. You'll work, as long as you can work out how to write a class and the bits that go in it, and you get the gist of that, then you're okay. Then from once we get into some of the other stuff, so once we touch on SymPy from next week, the week after we'll then show you the object-oriented version of SymPy. But where it'll really sink in, the object-oriented stuff, is when we come on to the agent-based simulation stuff just before Christmas, using a package called Mesa, which is agent-based simulations entirely object-oriented because it's all based on having individual objects interacting. And so what you'll often find is that agent-based simulation is actually a really good way to learn object-oriented programming, because it naturally fits that structure. So a lot of people find that it sinks in once they get to the agent-based simulation, that they've kind of understood it. So we'll go over the basics today, so you're aware of that, and moving forward, you'll get to use this a bit more. Also this afternoon we're going to talk about plotting using MatPlotLib. That's nice and light. MatPlotLib is really easy to use. It's very powerful. There's lots of stuff you can do, but I'm going to show you some of the basics, how you can get some nice graphs out really easily using very few lines of code. And we're also going to touch on debugging. So this afternoon you are going to attempt Dan's Devious debugging challenge, an annual tradition with HSMA, where I've basically taken a piece of code that I've written, ripped it to shreds, and taken out comments, and you have to work together to try and work out what on earth this code's meant to be doing, and try and fix it. So and it's quite devious, but it's quite useful for getting you to really look over code, and particularly as you're learning code, to understand if you find out what's going wrong, it helps you understand the very syntax that you need. So hopefully that'll be really useful for you too. Okay, so we're going to start, though, much as we did last week, and we're going to have a bit of a warm-up, Python programming warm-up session. So you're going to go into your groups, and you're going to have a go at working through Python Programming Workbook 6, which should have got in the repository for today's session. Let's just bring that up a moment. Oops, we'll close that. So what you'll have, I'll talk very briefly through it now, and then you can have a look at this in your group. So basically, what I want you to do is, it's a single task, and I want you to write a function called prime checker that takes as its input an integer, and which returns a boolean indicating whether or not the number is a prime number. So you're basically going to write a function that will take an integer input and it'll work out whether it's a prime number or not, and spit out a true or false to say if it's a boolean or not. And then, so that's the first sort of key thing you need to do. And then what you're going to do is basically try using that function. So you're going to get the user to input a number, then you're going to call that function that you've written to check whether the number is prime or not with an appropriate message. And you get the user to keep inputting numbers they want to check unless they input 0, in which case the kind of program terminates. I also want you to put in a bit of exception handling around there to catch, users are mischievous and may type in things that aren't valid inputs for your function. And I also want you to try a little bit of pandas. So I'm going to get you to try storing your results in a pandas data frame. So it records the kind of run number. So the first number tested would be run 1, second number tested would be run 2, etc. And it indicates the run number, what number the user input, and whether it was prime or not. So you've kind of got a table that says the first number input was this and it was prime, second number input was this and it wasn't prime, etc. And the index you should set as the run number. Now, the key thing before you go into all of that extra stuff about getting user input, exception handling, and pandas data frame, focus on the first bit. How are you going to write a function that determines whether or not a number is prime or not? That's your first task. Okay. Now remember, prime numbers are numbers that are greater than 1, that are only divisible by 1 and themselves. Now, the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So you can use your code to check that they're coming up as prime and the numbers in between aren't. Okay, that's a good indication that it's working. I've also given you a little hint here and this may or may not make sense depending on how you decide to approach this, because there is no single right answer. The solution that I've got for this uses only stuff that I've shown you over the last couple of weeks. Okay, so you can do this using what you've learned, but there are lots of different ways in which you could approach this. But have a read of this hint, and if you find yourself going down a certain route, you might find that hint useful. And that hint is that if you have a for loop with a range where the two numbers are the same, that for loop will never run. Now you might think, what on earth are you talking about? How's that going to be useful? It may not, depending on how you approach it. Or if you go down a particular route, you might find, that solves my problem. Okay, so it's there if you need it. It's in the solution, that approach. But again, there's no single right solution for this. So what I want you to do is you're going to go into groups. I'm going to give you about 40 minutes. So we've got to about 20 past 10. The way I want you to approach this is, first of all, I would advise spending a few minutes at the start where you're just all reading through this and having a think about how you're going to approach it. Then as a group, I want you talking about how you're going to write a function that will determine whether a number is prime or not. Forget about the code for a moment. Just think, how would you do that? What's the logic you would need to use? Then, as a group, think about writing as code. So also just to say, obviously we're going to be keeping a close eye on the groups. We're conscious that the group working hasn't been working too well. So we're going to ask everyone to be working together in the groups for all of these exercises. Always have somebody who's going to be sharing the screen, and I'd advise that's not always the same person. So a good way to approach things would be to select someone different for each task to lead the screen. Doesn't have to be someone experienced in code, because you're all going to work on it together. So it doesn't matter. Just pick someone who's gonna kind of share their screen and go for it, and then everybody contribute in. I'd also strongly encourage, wherever possible, that you during the breakout rooms turn your cameras on if you can, because it will really help you all get talking to each other, which is really, really important. We don't want people sitting there in silence, because certainly from our perspective, and the feedback that we've got from a number of participants is we have no idea if these people are just fantastic and they've got everything and that's fine, or whether they're struggling, and we need to make sure that people aren't struggling in silence. Okay, so Elliot and I will be floating around a lot today, and making sure that everything is working as it should. So this is a good initial task to get things going, because you're going to talk about how you're going to approach this. You need to think a little bit about how you're going to approach this particular problem, because it's not entirely straightforward. In coding terms, it's actually pretty simple once you work out a way to do it. But there's lots of different ways you could approach it. So have a good think about that. Okay, so what I'll do, I'll open up the breakout rooms now. As they spend the first few minutes, I know people sometimes need a bit of time just to compute it. So take the first few minutes, just all read through it and come up with some ideas, and then have a chat about how you're going to try and tackle this problem, and then turn it into code. Start with writing the function though. That's the key thing. The most important thing is writing this function that will take an integer as an input and determine whether or not it's a prime number and spit out a Boolean. That's your key thing. All the rest, once you've got that, all the rest is kind of extras that you can gradually then build up after. Okay, so let me stop sharing. I'll open up the rooms now, and give you a wow, my Zoom has crashed already. Apologies. I will quit and re-enter. I'll be 2 seconds.
Well, this is one way to build the anticipation. Anyone got a drum roll?
Hi everyone, sorry about that. My Zoom has crashed already. It's going to be one of those days. I could feel it already. It's not going to like me. So, okay, right. As I was saying, hopefully you caught most of that. But I'm going to open up the breakout rooms now, and Elliot and I will float around and see how you're getting on. So we'll zoom about 20 past. So you've got about 40 minutes. Hi everyone. Okay, welcome back. So I wanted to give you a little bit longer there because I could see well, I think all of the teams are on absolutely on the right lines with this, and I could see that you're all sort of getting there. So I wanted to just give you a little bit longer to do that. Also, can I just say it was fantastic to go and see all of the teams working so fantastically on this exercise. You all had cameras on, you were talking to each other, you were working out how to solve this as a group. That was fantastic to see. So well done, everyone. That was exactly how we want the groups to work. So so keep that up for the other exercises. And I think probably because of that, that you all actually got the pretty much the gist of how to do this. So a few of you sort of went off maybe in the wrong direction, doing some of the sort of frilly stuff around the edge, but at the core you all had absolutely the right idea for how to approach this. So that was really good. So what I'm going to do, I'm going to very briefly whiz through the solution. You can have a look at it. I'll upload it obviously after the session, so you can have a look at it in your own time. As that is not the solution, it's a solution, and there may be alternative ways that you might have approached this, but I think all of you were kind of getting to the point that I came to for doing this. So let me share my screen, and I will bring up the solution. Okay, so let's bring that down. Forget about all the pandas stuff and the user input stuff for a moment. At its core, this is the most important thing that I wanted you to do was write this little bit of code. Okay, writing a function that will check, basically take as an input a prime number, and it'll say it'll check if that number's prime or not, and then spit it out to indicate whether it is or isn't as a Boolean. Now I see quite a few of the groups were like looking at putting some of the other stuff that I then told you to do inside the function. Now you could do that, but my advice, and this will come in time, whenever you write a function, think of functions as doing something very specific and very simple well. Okay, so this function will check whether a number is prime or not. That's a very specific, simple thing. Okay, and that I would keep that as a singular function, because you could put all the user input and everything in there. But then let's say that you've got another situation, it may be in a totally different code, a piece of code that you're writing, where you want to also check a prime number, but you don't want user input, you're going to check it from a file. That function then becomes useless because you've put in all this user input stuff that you don't want. So you want to make them as generalizable as possible, so you can use them as much as possible elsewhere. And so by getting it down to a very specific thing, this is a prime checker that we can call, in this case where we do get user inputs, but equally we could also write a piece of code that reads in some numbers from a file and then chucks those numbers into this function, and it wouldn't matter. We can still use the prime checker. Or we could run a model, and then I don't know why you'd want to do this, but let's say the output, you wanted to check whether the output, the waiting time, was a prime number. You could do that using this function. So make them as generalizable as possible. So think about making them sort of atomic and simple, very specific in what they're trying to do. But as I say, the gist of what you had was absolutely spot on. So essentially here I've called my function prime checker. It takes as an input what's going to be a number that's going to be passed in an integer. And basically the first thing I'm going to do is check if it's less than or equal to 1, because we know if it's 1, then it's not prime, and therefore we can immediately return false. We don't need to do anything else. Whereas, and it'll never get less than 1 because of the logic down here, but in this function it could. So if it's less than or equal to 1, return false. But if it's not, let's assume it's 2 or more, then this is where the real magic happens. This is, I was delighted to see that you pretty much all had this. So it's the idea that what you're essentially wanting to do, we know that a prime number are numbers that are greater than 1 that are only divisible by 1 and themselves. So we can use our friend modulus, which comes in handy for lots of stuff, as you've seen over the last few weeks, to basically try lots of numbers, opt to the number that we are opt to, but not including the number that we are testing, to see if we can find a number that divides into it. Because if we exclude 1, we know it'll divide by 1. Every number will divide by 1, and we exclude the number itself. If we find any other number that divides into that number, then it can't be prime by definition, because a prime number must be greater than 1 and can only be divisible by 1 and itself. So if we find something in between that it's equally divisible by with no remainder, then it's not a prime. So essentially this is what this little loop does. It goes through from the range 2, because we don't want to start at 1 because it will be divisible by 1. So we start at 2 and we go opt to, but not including whatever number is passed into the function, because remember, it will be a prime number will allow it to be divisible by itself. So we'll go opt to, but not including the input number, and basically we'll just check each number in that little range between 2 and the number below the input number, and we'll do a modulus on it. We'll take the input number modulus whatever number we're checking at that point in the for loop, and if that's exactly equal to 0, then that means you found a number other than 1 and itself that divides into it equally. Therefore, it can't be prime. So you can immediately return false. And by calling a return statement here, remember we're in a function, that will immediately terminate the function because you've chucked out an output. So it'll stop. The for loop doesn't need to do anything else, doesn't need to check any other numbers, because it's found something that proves it's not prime. Therefore, we can call a return statement to say, right, I've finished, return this output. And we return false here. But assuming it got all the way through that loop, and it didn't find something that within that range of between 2 and 1 less than the input number, that divided equally into whatever number we've passed in, then we must have found a prime number, because therefore there's nothing that divides into it other than 1 and itself. So at that point we can return a true. So we're basically going through and we're checking each number. If we find anything that disproves that it's prime, we'll immediately stop and return a false. But if we get all the way through, then and we didn't find anything, then we return a true. It must be a prime number. Okay. Yeah, there's a hand up, sorry.
Hi, it's Rachel here. Can I just ask a couple of questions? So we were trying to define our function in line with slide 4, I think it was, from the other day's lectures. And on that slide, under the def line, it had a result line, we weren't, so we were okay about, we defined our input number. We thought we had to define our result at that stage before we went into the if bit.
Oh, I see. So yeah, so in that example, we basically had a variable that we wanted to pass back. Here, we're just passing back a Boolean, okay? And we can just, Booleans are basically just trues and falses. They can only have 2 values. So you could set up, if you wanted to, you could have a variable that would store true or false and return that. But you don't actually need to do that here. And
Okay.
because it's just a Boolean, you're just saying true or false. You can just return true or false as the value. You could technically do that with any variable value. You could return the number itself, but generally speaking, you'd want to maintain a variable. But if it's a Boolean, you tend to just return true or false.
Okay.
That's all you need.
And the other bit I want to say about for the I in range 2, input number, so that is going up to the input number less one, isn't it? So that's why.
Right. Yes.
Okay.
Yes, you're using the trick of the for loop that it won't go to the top of the range.
Okay.
Therefore, you're excluding 1 because you know it'll be divisible by 1, and that doesn't help you with prime. And you're excluding the number itself. So if there's anything else in that range that divides equally, then it can't be prime. But if there isn't, then it must be.
Great, thank you.
That's the little trick there. And of course, the reason I gave you that was that if the user should input 2, then of course that is a prime number. But what will happen is you'll say for I in range 2 to 2, that loop will never run, and therefore it'll immediately exit this and say return true. It is a prime number. So it just gets you out of that little wrinkle. You could, well, no, you can't do it separately because you need to check 2 on each number as well. So all the way, I won't go through the rest of it in detail because this was the main bit I wanted you to get, and I'd say most of you were there with it really. But the other stuff you can sort of look at in your I'll just very quickly go over it. So I've set up a data frame here to store the results. I start the run number at run number 1. And basically I've just got an infinite loop. So remember, easy way to set up an infinite loop, a deliberate infinite loop, is just to use the statement while true, because true is always true, and that sets up an infinite loop. And then we can just put in here all of the stuff that we want to keep doing. So we've basically got a big try except statement where it'll try and get a number from the user and turn it into an integer. That's where it could go wrong. So at that point, it might accept down here and say, look, it's got to be an integer, try again. And because we're in an infinite loop, it'll go back up here and try again. If the user inputs 0, then we'll exit and we'll print whatever the data frame is at that point, which will be empty if they haven't input anything. We can use a break statement to get out of the while true. So we're in an infinite loop, but we can still break out of it. So if we use a break statement, that will get us out of this loop. But if the user didn't input 0 and they input something else, then we can call our function that we've written up above. That, remember, returns a Boolean. It'll be a true or false. So the variable that we assign here, that I've just called is it prime, that will be turned into a true or false after that function is run. And then I can just check. So if it's true, I'll print a message saying, yep, it's a prime number. If it's false, it's not a prime number. And then I'll set up a little a data frame and append that onto my existing data frame. And I'll store the run number, the tested number, and so the number the user input and whether it was prime or not. Okay, but I'll let you look through. Sorry, and I also increment the run number at the end. So basically, it will keep looping through until the user inputs 0, and that's the only point at which it will break out of this while loop. So it's quite a handy thing where so in practice, as I mentioned, there's not going to be a lot of situations where you're doing proper data science where you're going to want the user to have manual inputs because you'll usually be reading in from files, etc. But there may be circumstances where you've got an infinite loop, or you want an infinite loop and you want to break out of it, and that's an easy way to do that. Yeah, there's a hand up, a couple of hands up.
Hi, just we were wondering in our group about whether when you're just appending something into the pandas data frame, will it auto assign it an index? Do you need to append the run number?
Yeah, so if you didn't put that in, it will automatically set up a brand new column that will be its index, and it will start at 0. So you don't have to do that, but for this we want the run number to be the index, because we want to be able to refer. Let's say we might want to then look up what was the the third number on run number 3, the third number that was input, was that prime or not? And so we could just refer to that index. So we haven't done it in this piece of code, but that's where we might want to use it, and that would make more sense than having the index starting from 0, because then we're asking the user to know that you start counting from 0, and that may not be a friendly thing to do. So it's just a small,
Okay.
And there was another hand up, sorry.
Yeah, Dan, I wanted to ask if the data frame you created, is it not going to create that every single time you're running inside of the while loop?
Yeah, so basically what you've got here is this initial data frame that's going to be the one that will be gradually built up, which starts empty. And then you've got this kind of temporary data frame here, which will basically, you're creating a temporary data frame with the results from this run, and then you whack it on to the end of your blank one. But you're right, every time you go through the loop, it'll create a brand new temporary data frame.
Oh, okay, I see. It makes sense.
So make sure that you have a read of the link that I sent, because this approach is being deprecated. So the append method is not now the recommended way to do it. It was for a long time. So I did put a link in Slack, so make sure you have a look at that to see the new method to add extra things to a data frame. But I haven't had a chance to update any of this for the solution. So this will currently work, but in the future, in a future version, it won't. So be aware of that. Okay, so that's the solution. As I'll put that up after the session so you can have a proper read of it. But the main thing I wanted you to get from this really was the rest of it was just to get you practicing some of the stuff we covered last week. But the main thing was this about writing the function and getting you thinking about how you'd solve a problem like that. Okay, let's let's move on and start with the lecture. And let's talk about object-oriented programming. So object-oriented programming is basically the preferred way in which we should structure anything that isn't a kind of tiny piece of code. Okay, so object-oriented coding would be overkill for something like you've just written. If that's all you needed, something like that, then that would be ridiculous to write that as an object-oriented piece of code. However, if you're writing something more significant, which most of you will be for your projects, then actually you should be starting to think about structuring your coding in an object-oriented way. So let's remind ourselves a little bit about what we talked about in terms of the object-oriented programming, what that means back in the first training session. So actually, I'll skip that first example and start with the second, because I think it's a bit easier to understand. So basically, in object-oriented programming, we have these things called classes. And a class is kind of like the generalized description or blueprint for something. So we might have, we might say in our program, we are describing something called a patient. And this is what a patient looks like. A patient has attributes. So each class has attributes and methods. Attributes are basically just variables that belong to that particular class. Okay, and similarly, methods are just functions that belong to that class. So that's all they are. So you've already seen variables, you've already seen functions. Attributes and methods are basically just those things, but they belong to a class. So a patient may have certain attributes that belong to it, like its name or its patient ID or its age. And similarly, it might have methods that belong to that patient. A patient may be able to attend DD or receive treatment, for example. Okay, so there are variables which we call attributes that belong to that class, and there are functions which we call methods in object-oriented programming that belong to that class. Now, the power of object-oriented programming is that what we can do is we can define what our class looks like, so what a patient looks like, and then we can create lots of them that all have their own name, patient ID, and age, and we don't have to recreate them every time. We just say, oh, it's one of these things. we've defined what it means to be a patient, and we've defined that in our class. And then we can just create lots of them and say, well, okay, this is a patient whose name is Bob Jones with this ID and is age 64. This is a patient called Mary Smith with this ID and she's age 51, etc. So we can just create lots and lots of patients very quickly just by defining what it means to be a patient once in terms of the attributes, the kind of variable values that it will have, and the various methods that it will have. And this turns out to be really useful for structuring our code. So just going back to this example, we could imagine this is the first one we looked at in the first session. We could imagine we've got a class called vehicle. We want to define what it means to be a vehicle. And a vehicle may have a common name, a number of wheels and a capacity, and it might have a couple of methods that you want to drive the vehicle at a certain speed and park it in a certain location. And we can define what it means to be a vehicle. And then we can create in our code lots of separate vehicles that we can then run with. So we could have, okay, I'm going to create this vehicle, and it's going to be an ambulance that's got 4 wheels and capacity of 3. And I'm going to create this vehicle, which is a bicycle with 2 wheels and capacity of 1, etc. Okay, so we can set up the generalized description for what one of these things is, and then set up lots of examples. And the examples are known as objects. And these are instances of the class. And this process is known as instantiation. It's creating an example of this class, an object, an instance, from this blueprint, from the class itself. That's known as instantiation. You instantiate something. You're creating an example. For those who didn't see it, I thought Mike's example in Slack was fantastic of thinking about object-oriented programming. A class is like saying, I'm going to tell you what a dog is, and an object is saying, I'm going to tell you about my dog. Okay, that's a really neat way to think about it. You're describing the kind of concept of being something here in the class, and the objects are specific examples of that something, okay, that you can then work with. Now, you can probably already imagine how this kind of stuff, particularly this, would be really useful for modeling patients flowing through a pathway, for example, because you could define what it means to be a patient, give them all the attributes that you're going to want to store. So the patient can wander along, they're holding their patient ID. They might be holding, as we'll come on to in the discrete event simulation, you'll see things like they might be holding a probability that they're going to get admitted to the ACU or something like that. They're holding lots of information, and there's also various methods that we can run on those patients as well. Now, we talked about the process of instantiation, which is where you take the blueprint, the class, and you turn that into an example. And to do that, we need something called a constructor. And basically, a constructor defines, so we write a constructor in the class, and the constructor defines what happens when you say, I want a new one of those. So I want a new patient. That process of instantiation, creating an object from a class. The constructor defines what happens, how you create that. Okay. So what it'll do is it'll define the how the object's created, including what default values you might have, initial values that you're giving into the attributes, or anything you may want to run initially in terms of the methods, etc. And the constructor is a method within the class that has to be there. Okay. If you don't write it explicitly, as you'll see in Python, there is one in the background that's already there. So it has to be there. In a class in Python, you have to have a constructor because it needs to know what to do when it assembles one of these things. So that's what we covered before. Let's have a look at how we would do this in Python. Now, this isn't quite as imposing as it looks, because you'll see most of this is comments. All of this code, by the way, you've got, so I've got all the lecture examples are in the repository you've downloaded, so you can have a look at this and run these things in Spider or your IDE of choice. Okay, so let's have a look how we'd create a class in Python. We start here. We use the remember, for functions we use the def keyword to define a function. To define a class, we use the class keyword. So we say class, that tells Python, okay, I'm about to create a class now. And I've just called mine here, my class. Now note the capital letters. So I've been telling you for weeks, a common mistake when you're starting out in coding is that you give capital letters to the starts of variable names. The reason you shouldn't do that is because they're reserved for class names. So if you start with the capital letter, it means it's a class. Okay, so I've just called mine my class, not very imaginative, but for the purposes of this, it'll do. Now, what we can put in here, the first thing, we can put what we call class attributes. These are attributes that will always have the same value for any examples that any objects that you create from this class. Realistically, you don't tend to use these very much, so I include them for completeness, but particularly for the sort of stuff that you'll be doing, you won't tend to use these. You will tend to have in modeling, etc., you'll have variables that will be different for every page, or they may have default values, but you don't tend to have, don't tend to use this quite so much. But it is there, you can do that. Let's ignore that bit for a moment though. Let's start with the method. So what basically happens is we set up some methods, and the first method we should always define is the constructor. I just said we have to have a constructor. That's the one that defines what happens when you say I want a new one of these. And the constructor in Python is init. It's called init. And you can see there's a double underscore both before and after init. And init is an example of what's known as a dunder method. Okay, dunder is basically just short for double underscore, and they're also known as magic methods. I'm not going to go into detail about what that means, but basically magic or dunder methods don't require you to call them manually. So far, when you've written functions, I've said you write a function, but nothing will happen until you manually call that function. And the same is true with methods in classes, that nothing will happen until you can write them here, but you need to call them if you want something to happen. The exception is magic or dunder methods, which are called automatically. Python deals with these, and it will call them automatically when the time is right. So in the case of the constructor, it will call this automatically when you say, I want a new one of these. Python will run this method, and it knows to do that. Okay. So this is the main one that you'll be using, the main dunder method. It's the constructor. So basically what we do is we pass into the constructor anything that the constructor might need when we set up a new example of that class. So if we go back to the patient example, let's say I'm going to create a new patient. I'm probably going to need to pass in, when I say I want to create a new patient, what their name is, what their ID is, and what their age is. Okay, I'm going to need to tell the constructor to create a new patient that's called Bob Jones, who's age 64, etc. Okay, so this, like with any other method, we pass in the stuff that the function is going to need. So here I've just got a couple of attributes that we pass in. Now, just to complicate things a little bit, there's also, in object-oriented programming, this thing called self. This always has to be the first argument that you pass in to any method within a class. Now, basically, what self is, again, is a little bit complex, but essentially what it's doing is it's storing the copy that you create. So we create a class called patient, but when we want to work with patients, we create objects, we create the instances of that class. And self is where that copy of the class, which forms the object, is stored. Don't worry about that. The key thing you need to know is A, that you need to include it, and B, whenever you're referring to a specific example, i.e. an object, rather than the class itself, then you need to use the self keyword to say, I'm talking about something that belongs to me as the object. Okay, you'll see this here. So here we've got a constructor, we're passing in self because we have to do that, and then anything else we need. If you don't need to pass in anything else, you still need to put in self. And here I'm just going to basically set up a couple of attributes that I passed in. Again, not very imaginative what I've called them. I've just called them attribute 1 and attribute 2. This might be patient ID and age. And I set them to be the values that I pass in. I set those attributes to be those values. So remember I said that attributes are variables that belong to a class, belong to an object. So that's what we're doing here. This might be, and you'll see it's a better example in a moment where we see a worked example of this. It might be patient ID and age. So we're going to say, okay, the patient ID that belongs to you is this value. The age that belongs to you is this value. And that's what self dot does. It says for the particular object that's created, the example of this class, their attribute 1 is this. Their attribute 2 is this. Because remember, the whole point of object-oriented programming is that all the different objects can have different values. You've got patients with different names and different ages. So self dot means the attribute that belongs to you, this individual object. So all classes have to have a constructor, but you may also have other methods as well, and usually will. And you just write these exactly the same way that you've written any other function. Okay, so they're just functions. They just happen to belong to a class. So we use the def keyword, the same as we did with the constructor, and the same as we do for any other normal function. We give it a name, and we pass in anything we need to pass in. But because it's in a class, we have to pass in the self keyword first, because we have to pass in the kind of saved copy of this object so that we can refer to it. Okay, that's probably the most difficult bit to get your head around, but you'll soon get used to it if you think about self as being the thing that stores the copy, the particular example. So if I want to create Bob Jones as a patient, self, when I refer to self, I'm talking about Bob Jones's age, Bob Jones's ID, Bob Jones attending ED, etc. And of course, you may have other parameters that you pass in as well. So you might write that into a function. Let's have a look, because that's the kind of basic structure. But let's have a look at now how you do this for the class that we described before. So for the vehicle class, remember the vehicle class, we said we've got 3 attributes: a common name, a number of wheels, and a capacity. And we've got 2 methods: a drive method, which takes as an input a speed, so how fast to drive, and a park method, which takes as an input a location of where they should park. So here's how I'll set up my vehicle. So I define my, this is a class. I use the class keyword, and I use a capital letter, and I call it vehicle. My colon, and then everything in this indentation is now the class definition. So all of my attributes and methods. So first thing I need to do, I'm going to set up my constructor. So I use the def keyword. I use my dunder method of init. This is my constructor. Remember, I have to pass in self. That always has to be the first keyword. But then I also need to pass in anything else that I'll need to tell it when I say I want a new vehicle. And I'm going to need to tell it what the common name is for this particular one, how many wheels it's got, and what capacity it is. You'll see examples later where you don't always have to pass stuff in. So you might have default values that will, or whenever you create a new vehicle, you always have this default value that can change later, but you don't need to pass it in when you create one. But we'll imagine here we do for these things. So we pass in common name, number of wheels, capacity, and we need to set these up as attributes of this class. So we say self.common name, which means when you create a new vehicle, that particular vehicle, its common name will be the common name that I tell you. Its number of wheels will be the number of wheels I tell you. Its capacity will be the capacity that I tell you. So what we've defined our constructor here. We're saying that when we ask for a new vehicle, you need to set one up, and I will tell you what its name is, how many wheels it's got, and what its capacity is, and you will store that against that vehicle. So then, if I then ask how many wheels has this vehicle got, you can tell me. But I'm also I've got a couple other methods as well as the constructor I need to set up. So I've got a drive method, which remember we're passing in a speed. And we remember always have to pass in self, regardless of whether we've got anything else. So self comes first, and then we'll pass in speed in this case. This method isn't going to do very much. It's just going to print a message saying I'm now driving at whatever speed miles per hour. The same with the parking. I'm going to pass in the location. Again, not a very exciting method here. It's just going to print a message saying I've now parked at whatever location we tell it. Okay. So that defines the class. So to define this class, that code will do it. So we now define what it means to be a vehicle. We've defined the constructor, we've defined the attributes, and we've defined any methods that it has. But in the same way as with functions, just defining it doesn't do anything. It just tells Python, this is what one of these things is. Remember this when I ask you to do something about it. So the function, we say, this is a function. When I call that function, this is what I need you to do. Here, we've said, this is what a vehicle class is. When I need one of these, this is what I need you to do. This is what I need them to look like. Okay. So we can write that vehicle class. It won't do anything. Python will just go, okay, I've remembered that. I'll bear it in mind when you ask me for a new vehicle. So we need to create an instance of the class to be able to use it. And remember, that's the process called instantiation. So now we've defined our vehicle class. Let's create an ambulance. Let's tell it to drive at 60 miles per hour and then to park at the hospital. So we've written our definition of a vehicle class here. So all I need to do now to create an ambulance is to create a new one of these things. So the way we do that, let's just focus on this bit first, is we use the name of the class. Okay, so it's a vehicle. Remember to use the capital letter because a class name starts with the capital letter. And remember that we said in our constructor that we will tell it three things. We'll tell it, we'll give it a name, a number of wheels, and a capacity. Those are the three things. When we say we want a new vehicle, we'll tell you those three things. So here's what we're doing. We say, okay, I want a new vehicle. And the three things are its name, which is an ambulance, it's got 4 wheels, and it's got a capacity of 3. Okay. And we're going to store that in here, which is, I'm going to call it my ambulance. My ambulance will now be an object. Okay. So what Python will do is it'll create through instantiation an object based on this class with the information you've passed in. So it'll create a new vehicle that's called an ambulance, that's got 4 wheels and a capacity of 3, and it will now be stored as an object called my ambulance. So now I can refer to my ambulance and it will be a vehicle that is called an ambulance that has 4 wheels and a capacity of 3. So all I need to do if I want to then tell it to run the drive method is I refer to my ambulance dot drive. I just call the use the dot notation, which you've already seen. You've already used bits of that when we talked about lists, for example, back in the first week, and we said here's a list, but you can call various methods that are associated with the list object. You're doing the same thing here. It's just you've written the class definition. So here we're saying, yeah, my ambulance, I want you to access the drive method. So I want to drive, and I'm going to I need to pass in a speed. So I'll drive at 60 miles an hour. And I'll call the park method on my ambulance, and I'll tell it to park at the hospital. So the dot notation tells it to access something about that object. It doesn't have to be a method. It can also be an attribute as well. So you can use that to access the attributes. It's a property of that object. Yeah, there's a couple of hands up. Sorry.
Hi, it's Rachel again. Can I go first?
Yeah, sure.
So I was following you up until the point you said the object name my_ambulance.
Mm-hmm.
So in terms of so I use SQL and tables and data warehouse. So I can see how a table is the same as a class, and the kind of field names are the attributes, and then each row of data would be an object in that table. But where would you? What is the object name, and how would you see that in a? I mean, you don't see the object name in a table. You would have the field ambulance or name, and it would be the value ambulance. So I'm not explaining this very well, but I can't
No,
quite get my head around how an object has a name as opposed to the values in its attributes.
Okay, no, I get what you're saying. Don't think about it in terms of tables. So this goes back to what I was saying at the start. The object-oriented programming is very different. So essentially what you're doing is you're creating a class. You're saying that this is what one of these things looks like, and then you're telling Python, I'm going to create some specific examples of this, and this one I'm calling my ambulance. I could call it Dan's ambulance, or lemon slice. It doesn't matter. You could call it anything you like. What it's doing in memory is it's creating a new one of these. So much like you create a new variable or new pandas data frame or all the things that you've seen so far, here it's creating an object, and it's stored in Python memory as an object. It knows what that is.
You've got that name though. I can see how you've got these attributes, and you could say, show me all the attribute values, so you could find Bob, for example. But what if you've forgotten that you've called this object my_ambulance, or my overthinking this and just let it go and see what?
Yeah, so it's think of it like it's more like a variable than a lookup in a table. So it's in the same way that you would give variables names throughout your code, and then refer back to those variables. This here is essentially, it is a variable. It's of type object, and you'll see when you create objects in the variable explorer that you've been using in Spider, you'll see these things come up, and it's like obj. And it's a variable of type object. So it's just like a number or an integer or a string. It just happens that this is a type object. And the way those objects work is defined in the class. So you're creating your own type of variable, basically. It's more like that than a sort of entry in a table.
Yeah, okay, thank you, that makes
sense. I think there might have been another hand up as well. Or I may have answered it, possibly.
Dan, I think you actually can check the ID. So if you pass like my ambulance ID, you can check that they have a different number. Each instance will have a different number, the way it's mapped. Is that right? As you do for any variable?
Yes, that's right. So you can we'll see examples of that where you can access the methods and access the variable values for that particular example, that particular object. And you'll see examples of that this morning where you can bung them in a list and say, tell me what the ID is of that object, etc. Okay, so yeah, that you'll see examples of that. Okay, so remember, the beauty of object-oriented programming is that we only need to specify the class once. We only need to say what, so in this case, what a vehicle is, and write the methods for it and the attributes. But then we can generate as many instances of it as we like. Just really simple. So here I can create another vehicle that I've called Mike's ambulance, and that's a vehicle that has a name of a common name of ambulance and 4 wheels and a capacity of 3. I could create another one that I've called Sean's car, and that's a vehicle that's a car that's got 3 wheels and a capacity of 2, etc., etc. So just with a single line of code, I can create another example, another object that has different values. So now I've got here I've got 4 different vehicles, all with different names, or different common names, different numbers of wheels, different capacities, etc. And I can deal with those separately. So then if I want to do something with Sean's car, I can say Sean's car .drive, and it'll drive Sean's car. So I can deal with those things separately. So let's imagine that we want to add an attribute called owner to the vehicle class that we've written. So this is all the same as before. And I want to have the owner displayed in the message when the drive method is called. So I'm going to pass in now, instead of 3 things, I'm going to pass in 4 things. I'm also going to say to the class, when I tell you I need a new one of these things, I'll also tell you who the owner is. So here I'm going to pass in an extra attribute called owner, and that's going to be set up in the constructor. So you say, basically, the owner I tell you, I'm going to tell you an owner, store that as your owner when I create a new one of you. And then I'll just change my drive method. So here I can change my print message, excuse me, so that I can refer to the owner. And the reason I'm showing you this is because it shows an example of how I can refer to an attribute that belongs to this object. So when we create this object, the object will have an owner, and in the drive method, I can refer to that attribute just by saying self dot. And remember, self dot will allow me to refer to a method or to an attribute. So here I'm referring, if I say self dot owner, it means grab me the attribute, give me the value associated with the attribute that you've got called owner. Okay, so self dot is when you're talking within the object. It says, what's my owner? Whereas back here, when we were talking externally, this is basically the same self. It's just saying, okay, my ambulance dot park. It's saying the ambulance that I've created, the vehicle I've created called my ambulance, call its park method. But within the class, we refer to self because it's referring to itself. Okay, it's a bit weird, but you will get used to it. But basically, in both cases, you're then able to access the attributes and methods that belong to that particular object. This is the most common bit. Traditionally, this is the bit that people forget to do when they're writing class definitions. They forget to use the self dot. If you're referring to one of the attributes, you need to, or even one of the other methods, you need to write self dot, because you're saying it's the its owner is the variable, but it belongs to me. So I need to say self dot. It's the variable called owner that I have. That's what's known as an attribute. This will make more sense as you get to use this as well. Sorry, I was also going to show you down here. So this is a good example. So I said self dot is kind of when you do it internally in the class definition. And then externally, I can do the same thing. So I might print a message down here after I've created Tom's monster truck and say Tom's vehicle has, and then I can give the name of the vehicle that I created, the name of the object. In this case, I called it Tom's monster truck. So it knows it's talking about this particular example. And I'll give it, I want to grab out the number of wheels. So what it'll do is it'll go into here, and it'll grab out number of wheels that belong to Tom's monster truck. It's a good way to think about objects as being individuals that are carrying with them. They don't have to be human, of course, or even living things, but they are individuals that are carrying with them some information, which are the attributes that belong to them, and some things they can do, which are the methods. Now, talk a little bit more about the constructor. So I mentioned a moment ago that not all of the attributes have to be passed in externally. You could have attribute values that you'd always have a default value. So here's an example of when you might want to do that. So here I've created a class called student. I'm defining what student is. I've just got a constructor here for simplicity, and I'm going to pass in a name, but I may have 3 attributes to do with students. So I need to tell it when I create a new student what their name is, but you may have some defaults that will always be the case when you create a new one of these. So in the case of students, if you create a new student, we know that they haven't completed the course, so I'll set that up to be false for every student I create, and I'll start them at level 1. So we don't need to pass those things in. So that means then when I create a new student, which I've just called my student here, I only have to pass in what I've told it. I'll tell it. So here I'll tell it the name, and it'll set that up against the attribute, against that object. But the attributes completed course and level, I don't need to pass that in because they'll just be set to false and 1 for each one. I can change those things later, but when I create a new one, remember that's what the constructor's doing. It's telling it what to do when it creates a new one of these. If we don't need to pass this in, if it's always going to be the same default value when you create a brand new one, then we don't need to pass those things in, and we can just set them up in the constructor with default values. And also, just to flag up that the names that you pass in, a bit like functions, don't have to match the names that you're referring to as the attributes. They usually will. So here I'm passing in a thing called name, and I will store it as an attribute called name. So I say self.name equals name. But those two things are technically different. This is the thing that is being passed in, and this is the attribute. Now you're going to store the thing that's been passed in. You can take the value and store that in the attribute. So you tend to use the same name, but it doesn't have to be. So I could have self.name equals full name, and full name is the name of the thing passed in. It's the same thing, okay? This just means I'm expecting, ignoring self, I'm expecting 3 inputs. So when you create a new student, you better give me 3 things because I'll need them. And then here it says you can refer to those 3 things that have been passed in and set them up however you like. Okay. First thing we're going to do is take a break because it's been a lot of information to take in. Then you're going to have a go. You're going to work back in your groups and you have a go at doing this. Please don't panic if you don't get this immediately. Object-oriented programming is not 100% straightforward, and for reasons that you've already encountered, it does require you to think in a slightly different way. Good way to think about it, as I say, is to think about it as a almost like you've got a blueprint for something, and then you say, I want to create specific examples of that. Okay, so the way that will make most sense, I think, to a lot of you will be thinking about things in terms of having a patient, lots of different patients that you might have in your model. So this will get you, this is going some way towards where we'll be going with SymPy and how you'll be doing things in that. So we're starting to get towards more applied stuff now. So what you're going to do in your groups after you've taken a break, you're going to write a class definition in Python for this class, a patient class that has these attributes: a name, a patient ID, an age, and a Boolean value of cured, which defaults to the value of false. And then a couple methods that can be run on patients. One is to attend ED, and we pass in an average time they spend in ED. And one is a method where they receive treatment, and we pass in the probability that they're going to be cured. Okay. So there's a bit of explanation here about, so the first thing I would do is to set up the structure of this. But of course, you need to know what to write in these methods. So these 2 paragraphs here define what I want these methods to do. So basically, the attend ED method will randomly sample a time based on whatever mean is passed into it, which will represent however long that patient's going to spend in the ED and print some message, etc. The way I want you to do that is to sample from an exponential distribution. We talked about distributions back in the first session, and I said it's typical in modeling that we use exponential distributions initially because they're easy to play with. The way you do this in Python, because I haven't shown you yet, is you use you import the random library, which I have shown you, and you use the expovariate function of the random library. So you call random.expovariate, and you pass in something called lambda. Now, don't worry about lambda at the moment. All you need to know is it's 1 over the mean. So if your mean is 5, then the value you pass in is 1 over 5. Okay, that's all you need to do. Then you've got a separate method here called receive treatment, and that's basically going to determine whether the patient's cured. So you've got one that determines, essentially, randomly works out how long the patient's going to spend in ED, just randomly samples that from a distribution, prints out a little message. The receive treatment one will randomly determine if the patient's going to be cured or not, and print out an appropriate message and update the cured attribute if they are. In order to do this, and I want you to think about how to do this, you can also use something called the uniform distribution. We talked about that distribution back in the first session. We said the uniform distribution is just a distribution where any value is equally likely to be selected. So if you say uniform 0 and 1, it means give me a random number between 0 and 1, and any number is equally likely. Okay. That is a really useful, it's not very useful for, you never want to use that for something like sampling a time that you spend with a nurse, because you could have all sorts of, it would mean that they're equally likely to spend a minute as they are 10 hours. That's not going to be the case at all. But it does come in handy for modeling when you go down branches within a model. So think about how you might determine, using a uniform distribution and sampling from a uniform distribution, whether one thing happens or another. Because that's essentially what you're doing here. Are they going to be cured or not? And you need to randomly determine it based on this probability. So have a think about how you'd approach that. Both of these things you will be seeing in the SymPy stuff, and they will. So once you get to grips with this will stand you in good stead when we come on to SymPy next week. So once you've defined the class, then you're going to create some instances of the class, and you're going to call the methods on them and see what happens. Okay, so you write the class, then you'll try playing around with the class, create a new patient called Bob Smith, and tell him to attend ED, and the average time he's going to spend in there will be 30 minutes or whatever it may be. Okay, so just play around with it, but write your class first and then create some objects. Yeah, I saw there's a couple of hands up.
Only me again. I was just saying, I'm looking at that. I'm really quite confused about the receive treatment bit, but can we just call you in if we can't figure it out?
Yeah, don't worry too much about that initially.
Okay.
So the first thing I would do, write your class,
Okay.
set up the structure or your attributes, right? Set up the methods ready to have something in them. Then just look at these things one at a time. Okay, and then so when you get onto this bit, which is a bit more complicated, think about how you would do that. Forget about the code for a moment. Just think about how you would determine.
Can we use the age to just inform the probability, like the age of the whatever is the patient, to inform the probability?
You could do that. I mean, I wouldn't do that here because that'll complicate things. But yeah, you could absolutely do that. I mean, that's something you may want to do in a real world model, that you might use. These things might be interlinked. But for here, we're just going to assume they're separate. That you're
okay. Just sample randomly from uniform.
Yeah, so you basically just say, okay, Bob Smith, you're going to attend.
Yeah. Okay.
You're going to receive treatment, and the probability you'll be cured is 50% or whatever. That's all you're going to do. Okay. So yeah, go and have a 10-minute break at least. So I'd break to sort of gone 1/2 past, maybe even 25 to, and then I'll give you about 45 minutes, but I'll float around and see how you're getting on as well. And just have a go. Again, do exactly as you did this morning. Get someone to share their screen. Spend a few minutes at the start just reading through it all, but don't worry about all the details initially because there's a lot of information there. First thing you want to do is create a class with the constructor and the method set up. You don't have to write them yet, just put them in the framework for them, then take them one at a time and then build in the attend DD method to work out how you'll do that, and then work out the same for the receive treatment method. Okay, so go and take a break. I'll open up the breakout rooms now so you can dive back into them whenever you like, and have a go, and we'll float around and see if you need any help, but all chip in and have a go at this because it's not easy. But if you can get the gist of this, then it'll stand you in good stead moving forward, because SymPy, you're getting towards what SymPy does. Okay, I'll stop sharing, but go and have a good stretch of the legs. Don't think about Python for at least 10 minutes. Okay, welcome back, everyone. So I thought I'd bring you back a little bit early because I was really impressed. Every single group had either finished or were pretty much there, and got all the sort of key bits. And you should be very proud of yourselves because I would argue this is probably, of the 3 sort of Python intro sessions, that's probably the hardest task. You're going to love this afternoon because after object-oriented programming, MatPlotLib is going to seem a doddle. You're going to be good. You'll get annoyed with the debugging, but it's not hard. It's just frustrating and relentless, and it's supposed to be. But I would say this is probably the hardest one to get your head around. In fact, so my colleague Tom has been teaching undergrads for many years, and always said that the people that are studying computer science will struggle sometimes to get object-oriented programming. So this isn't an easy thing necessarily to get your head around. Some people will get it more quickly because it's a different way of thinking. But it will come, I promise you. And this is it's hard but important, and you will get lots of chance to see this in action as we move through the course. When we come on to SymPy next week, I will show you the non-object oriented way first next week, but then the following week I'll then show you how to do it in an object oriented way, and you'll find that it's when you've got a very easy SymPy model, very sort of straightforward, simple model, it seems overkill. But the second you then go beyond that, you'll see how much more elegant it is writing it in that kind of way. So you'll see where this really sort of comes into its own. So I'm just going to scoot through the solution very quickly. Again, I'll most of you seem to get this anyway, so but I'll also post it up so you can have a look in your own time. And then I'll just go through a little bit more of object oriented before lunch, just to go through another little bit that you might find useful. So let me just share my screen, and let's bring up the solution. Here we are. Okay, so what we've done here, I've imported. Remember, we always do our imports first. I'm going to need the random library. You'll get used to using the random library a lot when you're doing modeling, because as we talked about in the very first week, we use distributions in discrete event simulation, for example, in order to capture the real life variability, and the random library gives us access to things like the exponential distribution, which you will use in SymPy. So we'll import that first, then we're going to create our patient class. So I've used the keyword class. I've got a patient, use my colon. So then everything in this code block here is our patient definition. So Python will read this in, won't do anything with it other than remember it at this stage. So the first thing I'm going to do is set up my constructor. So there are 4 attributes that we need for a patient: the name, the patient ID, the age, and whether they're cured or not. This is the information that the patient will carry along with them. But only 3 of those things we need to set up when we create a new patient, which is we need to tell it their name, their patient ID, and their age. We're going to assume that everybody is not cured at the start, so we don't need to pass that in. We'll just set that to cured equals false. So when a new patient's created, their cured status is automatically false at the start. Then we're going to set up our attend ed method. So here again, we need to remember to pass in self as the first argument, and then if we've got any others, we'll put them in after that. So in this case, attend ed, we're going to pass in a mean time. It's a slightly weird example, this one, because I try to keep it as simple as possible, but also touching on what you'll be doing in when you come on to SymPy. But that means it's a bit of an odd example. So essentially what you're doing by passing in a mean time is you're saying this is the average time that a patient would spend in ED, and for this patient we're going to take that average time, and then we're going to randomly sample from an exponential distribution that uses that mean to work out how long this patient spent in ED. Okay, so this is what the random.expovariate's doing. It calls a function that will randomly sample from an exponential distribution, and an exponential distribution is it's essentially so any distribution, you define its potentially its shape and its size using a number of parameters. With the exponential distribution, the reason we recommend using that for all your distributions initially when you build a model is because it only takes one, and it's one that you can easily ask people who you're working with on the real world system and say, how long is the average time patients are spending in ED, and you can change that. So in Python, for the random.expovariate, it actually takes lambda, which is just the inverse of the mean. So we just take in whatever mean has been passed in, and we pass to the expovariate function 1 over that. Okay, that will just give us the inverse. So it takes the mean. So if it's 0.5, it'll call the random, the expovariate function in the random library. It'll sample then from an it'll create an exponential distribution with a mean of 0.5, and then or a lambda of 2 if you like, and it will randomly pick a number, and the probability of those numbers will follow the shape of the exponential distribution. So lower numbers will be much more likely to be picked than higher numbers. Okay, So it then randomly pick a time that this patient will spend in the ED. And then it'll print a message saying that this patient spent that long in ED. And remember, if we need to refer to attributes of the object, we need to use self. So self dot means grab this patient's ID, grab this patient's name. Okay. We don't need to do that for time or the time spent in ED, because that's not an attribute of the patient. That's just a little variable of this particular method that we just use to, we take the sample, store it in there, and then we'll print it out. So we don't need to store that against the patient. We could set up it may be that you'd want to store that and say, okay, we'll randomly sample it, but then we'll store that as an attribute of the patient. So we've got a record of how long they spent in ED. You may actually want to do that. And in that case, you'd have up here a self dot time spent in ED. And you'd set that up. You might start it as a 0 because they haven't spent any time when they're first created. And then you'd update that here by saying self dot, and then it would refer to this attribute. Okay. So that you may want to do that, but for this, we didn't need to do that. And then the receive treatment function. So I was really pleased to see most of you got there. This is something that you will have to do a lot in modeling. It's where you basically have, not everybody follows a linear path. So you will have, in discrete event simulation, for example, people going off down different routes. And you'll typically represent that in a discrete event simulation as a probability. So you'd say, well, after attending ED, 20% of people are discharged, 40% go into the ICU, 50% go onto a ward, whatever it may be. So the way you do that with SimPy and with other models, an easy way to do that is to basically use the random library and use the uniform distribution and take a random number between 0 and 1 with all numbers equally likely being picked. That's what the uniform distribution does. And then you'll say, is that less than the probability that I'm looking at? So let's think about that. If your probability of being cured is 40%, then if we randomly pick a number between 0 and 1, then 40% of all those numbers that we could pick are below 0.4. So therefore, there is a 40% chance that you will pick a random number between 0 and 0.4. And therefore, that emulates that probability. So it's a really handy thing you can do. Similarly, if the probability was 100%, then there's 100%, all of the values fall below 1. And so therefore, that works there, etc., etc. If it's 0, there's no values that fall below 0. So it's a really handy way, and you'll use this a lot, where you basically, if you've got a probability, you're going to use that to determine whether one thing happens or another. And you'll randomly sample from a uniform distribution between 0 and 1, and then you'll compare that number to the probability. And if it's less than that, you'll say, oh, that thing has happened. So in this case, are they going to be cured or not? We take a random number between 0 and 1. If that's less than that probability, then they are cured. If it's not, then we say they weren't. And that emulates that probability very nicely. So if they are cured, then what we're going to do is we're going to set our cured attribute to true. So we have to use self dot to refer to our attribute, the attribute of the patient. And then down here, we've got this extra bit of logic that we say, well, if they were cured, and we know that because we can check whether their cured attribute now says true, then I'll print a message saying they were cured with a probability of blah, blah, blah. Otherwise, I'll say they weren't. And then we can try that out with some patients. So if I do that here, if I run that code, I've put in Bob Smith with that number and that age, and then chuck in that I want Bob Smith to attend ED. The averaged mean time in ED would be 60 minutes. Bob Smith actually was in the ED for 26 minutes. So although the exponential distribution had an average of 60, the particular time sample was 26. And we put in that there was a 30% chance that they would be cured. So we randomly sampled, and they were. So actually, that was quite good going, because 30% wasn't great. Then we tried it with Mary Jones. Mary Jones, the average time was 180. and that in this case it was sampled that she was in there for 47.4 minutes. And Mary Jones had a much higher chance of treatment of 0.8, and she was indeed cured. But if we ran that again, of course, we'll get different things coming out. So this time Bob Smith, much longer time in ED, and same with Mary Jones as well, but they were again both cured. But if I run it again, Bob Smith this time was not cured. So things went against Bob on that particular occasion. So it just gives you, and also just to flag on, once you run, so I've done it here, I've set up these instances. Once you've run that bit of code that defines a class, you can, and this is the advantage of Python, and we talked about right at the start, that we can interact with it. So in memory now, because I've run this code, is a class, and I've got a couple of patients set up because I've run that bit, but I could set up a new patient interactively live here without having to write it over there. So I could say patient 3 equals a new patient called Dan Chalk, ID 12345, and age 41. I've now created a new patient, and you see it comes up, if I move this, as a type patient. So where you've had variables here before that say it's an integer, it's a string, that kind of thing, this is a variable, it's of type patient. You've created a new thing, like an integer. An integer is an object. A string is an object. You've created a new thing called a patient, and you've told it what a patient looks like. It has these attributes, and it has these methods. And that's basically what you've done. So now I can interact with patient 3. I can say patient 3, attend DD, and the average, sorry, what am I doing? Patient 3 dot attend DD, average time 10 minutes. Ambitious, I think, today. And there we go. They're actually in it for a minute. Yeah, there's a handoff.
Yeah, then I just wanted to check or confirm, does the sequence matter? Rather than putting the name first, what will happen if I put the ID first before the name and then before the age?
Yeah, so in this example, yes, the sequence does matter. So it's expecting these 3 things, because what you're telling it in the constructor here is that the first thing that's passed in, that you happen to call name, but you could have called that, you know, lemon slice if you like, put that first thing that's passed in into name, put the second thing that's passed in as patient ID. So yes, it would matter. You can, in Python, you'll see later in the course, you can specify the variable name in here. So you can say name equals, and then it assigns it to that variable. So where and that's really useful. You'll get to use that in some of the more complex functions that you use, where you specify, there could be thousands of potential inputs, but you can't specify everything. So you just specify certain things, and you say the thing I'm referring to here is the name, etc. And you just put name equals whatever it is. But for this kind of thing, you just tend to have them in order.
Thank you.
Okay, so that's the basics of object-oriented code. And so hopefully that's given you, hopefully it's not quite as scary as you think. It's just that needs that little bit of extra thinking. It is something that you want to look back on though, and you'll get lots of practice using object-oriented programming throughout the course as well. But it seems like you've all sort of got the gist of it, which is really good. So just before we break for lunch, I'm just going to go through I'm going to whiz through this fairly quickly, because it's not something that you may necessarily use, but it is good to know, and it's quite a handy little feature. But it's something, again, you might want to play with a little bit more in your own time. So there is something in object-oriented programming called inheritance. Now, imagine we might have a class, we want to create a class, but actually this class that I'm creating is pretty similar to another class that I've already written. It's just got a few added sort of bells and whistles. So take the example we had before. Rather than set up an ambulance as an instance of the vehicle class, we might decide actually we want a class called ambulance. But an ambulance class is a lot like a vehicle class. It can still drive and park, and it has a number of wheels and all that stuff that we said is part of being a vehicle. But ambulances also have an attribute that indicates whether the siren's going off, and maybe a method that turns the siren on and off. Okay, so it's a class that we can, rather than creating a new vehicle that is an ambulance, we could say I'll create a class called ambulance, and then I can create lots of ambulances. But rather than recreating and rewriting an ambulance class that's actually very similar to a vehicle class, I can say an ambulance, it's like a vehicle class, but with these added extras. So it saves me having to rewrite everything that I did for a vehicle in the ambulance class. And in object-oriented programming, this is known as inheritance. So what we have, let's take that example. So we've got our vehicle class here. Let's just use a simplified version. Let's imagine we've got a vehicle class. It's got a number of wheels and a capacity as its two attributes, and it's got a method to drive. Okay, and we could use that vehicle class for lots of different things. But let's imagine that we also want to, because we've got lots of ambulances in our particular code, we want to create lots of ambulances. So we think, well, actually, it might be quite handy to have a separate ambulance class. So I could write a new class that has all of the stuff in vehicle, but also has some extras in it. That would be fine. You could do that. But you can use this little shortcut called inheritance to say, well, an ambulance, it's like these vehicle things. It's going to have all of that stuff. It's just, I'm going to put a few extras in it. And so we can do that via inheritance. Let's imagine our ambulance class. We're going to say it's the same as a vehicle class. It's just that an ambulance also has this additional attribute called siren on, which is a Boolean, indicates whether the siren's blaring or not. And it's got a couple of extra methods, one to turn on the siren and one to turn it off. Okay. Now, we can use inheritance to say that the ambulance class will inherit all of the stuff from the vehicle class to save us having to write all that stuff that's the same again. And in object-oriented programming, we call this the parent and this the child. So the child inherits from the parent. So basically the child class, in this case the ambulance, will inherit all of the attributes and methods of the parent class, but it may have some of its own. So here the ambulance has inherited these two attributes of the vehicle class and the method of the vehicle class, but it's just going to bung on its own as well. That means in Python terms, we don't have to write out the method for driving again, because, you know, I know in our example, it's just a print message, but maybe that's a really complex method. We don't have to want to write the whole thing again. We don't have to with this. We can just say, yeah, it's the same as a vehicle. It's just got these added extras. And fortunately, the good news is that it's really, really easy to do inheritance in Python. All you need to do, so we've got our vehicle class set up here. So this is the same sort of thing you've seen. We set up a class called vehicle. Here's our constructor with our three attributes. I've actually got three there. And here's our drive method. If I now want to create a child class that is like a vehicle but with some added extras, then I create the child class in the same way. So I use the class keyword, I give it the name, so I'm going to call it ambulance. But I use brackets and I pass in the parent class. And what this does is it tells Python, I'm going to create a class called ambulance, but by the way, this is a child of the vehicle class. In other words, I'm going to want all this stuff in vehicle as well. So we just pass in using the brackets the parent class, the name of the parent class. Then we set everything up in exactly the same way, but we don't have to set up anything that we've already done in the vehicle class. And instead, we can use something called the super function to basically tell Python, yeah, just do all that in the vehicle class as you would have before. So here, where we've got our constructor, remember we said that we want to set up the attributes to be exactly the same. It's just that we're going to have an additional attribute called siren on. That's the only way that it'll differ in terms of the attributes in terms of an ambulance class. So what I can do here in my constructor, I'm going to pass in, as we did for before, for a vehicle, number of wheels, the capacity, and the owner. But I'm also going to pass in something called siren on. And I can turn that siren on as I would before, but rather than having to rewrite self.number of wheels equals number of wheels, self.capacity, I don't have to do that because I've told Python that ambulance is a child of vehicle, which means all I need to do in the constructor is say super, open and close brackets, dot init. And what that will do is it will call the constructor of the vehicle class. And I pass across the number of wheels, the capacity, and the owner. So in that single line of code, it'll then say, oh, right, okay, yeah, I need to go back to vehicle and I'll use the constructor from vehicle. So this constructor, when you create a new ambulance, the first thing it'll do is say, okay, I'll call super and I'll run the constructor of the parent vehicle. So I'll set that up, and then down here I'll also set up siren on. So that single line of code just says, yeah, do everything that you would have in the constructor for the parent class. It's really handy, single line of code, because of course you could be setting up hundreds of attributes for an object. That single line of code saves you writing all that out again. You can just say, yeah, do all that. Here's the stuff you need to know. And then we can write methods in the normal way. So I can write some new methods in the ambulance class just by setting them up. Remember, I don't have to declare, it's already inherited any method. So it's inherited the drive method. So I don't have to specify that separately in ambulance. If I don't put anything in there, it'll automatically come with the drive method, and it'll just use the one in vehicle. But I can set up my own. But I can also, let's say that I do want the drive method, but I want it to work slightly differently for an ambulance. And let's imagine here, I'm just going to change it so that the message says this ambulance is driving at however many miles per hour. To do that, really easy, you just define the method again, and it'll overwrite it for an ambulance. So it's like, okay, when you tell me to drive, I won't use the vehicle definition of the drive method. I'll just use this one here instead. If I didn't put that in, it'll just use this one. So it's really easy. We just specify anything that's new, and we can just leave anything that isn't. Yeah, there's a hand up.
Hi, can you keep going? Can you have a child of a child of a child of a child?
Yep.
Yeah. Okay.
Yep. You can. I wouldn't recommend going down that route, but you can.
I just wondered.
If you had a very complex structure, then you can, because any class can be both the parent of a class and a child of a class.
Yeah.
So yeah, you can have entire family trees of vehicles and ambulances.
Oh, cheers.
Another hand up, sorry.
Is that me? Yeah, it's Tim here. I just wondered, why do you need to repeat the number of wheels capacity owner when you're inheriting? Does it not just take it as read that that's what you wanted from vehicle? You do have to explicitly put them all in. Yeah,
because it needs to know. So these things are things that we need to pass in. So when we create a new ambulance, we're telling it you will be expecting the use. When we tell it we want a new ambulance, we will tell you these 4 things: wheels, capacity owner, and siren on. If we didn't need those things, then no, you don't need to repeat it. But because we do have to still pass them in when we create an ambulance, we need to specify that. You'll find in practice, when you actually do these things, you'll have some things that you'll need to set up, a few attributes that will be you have to pass in the information, but a lot of it will be set to default values because it'll be stuff that changes over the course of the model. So you won't have many of these anyway in reality. But yeah, you have to say, it saves you having to set up all this bit, but you still have to tell it what you're expecting the user, not the user, sorry, what you're when you create a new one of these, what it will need, the information it needs, including.
Yeah, that makes sense.
Yeah.
Thanks.
Okay, so that's a really easy way in which we can inherit stuff, and it allows us. You may not use it, but it can be quite useful if you've got classes that are a bit like something else, but you may want to define them slightly separately. And the good news is, if you want to do that, you can see it's actually really easy to do it. Another thing that's worth pointing out, I said that objects, the objects you're creating are just like integers or strings, which are themselves objects, which means we can have a list of objects and loop through them, because you've already done that. When you created lists in the first week, you had a list of numbers and strings and stuff. They're all objects. You can treat the objects that you create in the same way. So here I've got my vehicle class. I've set up some example vehicles, and then I'm going to bung them all in a list. So I've got Mike's ambulance, Sean's car, Alison's bicycle, and Tom's monster truck. And then, just as you've seen before, I can iterate through each element in that list. In this case, each element is an object of our creation. And I can say, okay, in this case, I'm going to say, well, grab the common name of that object. If it's bike, then call the method with these parameters. Otherwise, call it with these parameters. So we can. This is basically just to show you can stuff all of your objects into lists. You can put them in dictionaries, etc. Because all the stuff you've done so far has been using objects. It's just their core Python objects that are already written for you. You don't need to write what an integer is, but it is in the back end an object. It's just that here you've created your own object. You've called it a vehicle, but you can treat them in exactly the same way. Now, a key advantage of object-oriented programming is it allows us to reuse stuff. It's the reusability that makes it so important. That means that we can write some code and then we can use it in lots of different places and even in a completely different piece of code. And that's really handy. So to do that, all we need to do is we can store a .py file, one of our Python files, that represents a module. And basically all a module is multiple class definitions and functions, and then we can import it elsewhere. We can either import the whole thing, or we could just import certain methods. I'll show you a couple of quick examples. Again, these are in the these Python files are in the repository, so you can play around with these yourself. So here I've got an example. I've called this file, I've saved this file called pen-called-wizardry.py, and in this file I import the random library. I've got a class which defines what a pencordian is with a couple of methods. And I've also got a standalone function. So that's not part of the class, that's just a function that I've written. And the reason I've done that is because it might be that I want to use the pencordian class somewhere else, or it might be that I just want to use this function that I've written. The standalone function might be useful elsewhere. And this one's going to turn people into a wizard. So what I can do in a separate piece of code, I can actually still use, so far, you've written class definitions and you've written functions, and then later in the code, you've then used them. But you can also write them and then use them in a completely separate file that you come back to later. So you could write something today and then in one file, and then say, actually, that function I wrote the other day, that would be really useful here. Well, what you can do is you can just import it. You don't have to write it again. You can just say, yeah, that thing, I want to import that thing I did the other day, and I'll use it again. And that's actually how you should be viewing objects and functions, as things you want to use time and again. So here in a separate file, I've just got to import code1.py. I import the random library, but I'm also going to import pen-called-wizardry. In other words, grab me everything in here. And by doing that, it will be as though everything I typed in this piece of code, I typed here. So it'll know what a pencordian class is, because I defined it in that file. It'll know what the turn into a wizard function is, so I can write it, I can use it in this file as well. And then what I can do in my, I've got a little list of names here. I can then do some things. I can randomly sample a few names from that list, and then I'll turn them, I'll create pencordians from them by passing in the name, which is what I defined here. Or I could call the turn into a wizard function. Yeah, there's a couple of hands up. I think.
Yeah, hi there. When we're calling the modules, I guess they have to be in your working library. I'm just a question around, you know, where does it know how to get the modules that you've created?
Yes, that's right. Yeah, so there are ways. So we won't go into it in the course, but there are ways in which you would, if you're doing this and really getting into it, you would structure your code with particular in a particular structure that would then look for various bits into. But for this kind of stuff that you're doing, yes, it will look for it in the same folder. Essentially,
yeah, okay.
You're working directly. Was there another hand up? Sorry. No, I think that might have been an old hand. Let's say as well, I've got a separate piece, as again another completely separate file. Let's say that I want to use, I'm writing a piece of code. I think, oh, you know, that function that I wrote back here the other day, turn into a wizard. I want to do that. I want to turn someone into a wizard. I don't need this pencordian thing, but I could quite do with that function. So what I can do, rather than import the whole of pen-called-wizardry, now here it's a pretty short file. This could be a file that's thousands of lines long, potentially. So you may not want to import everything if you only need to use one thing in this piece of code. So rather than import the whole thing and saying import pen-called-wizardry, what I can do, and you'll see lots of examples of this as we go through the course, especially when you get into the machine learning, there are thousands of machine learning packages. You don't say just import the lot. Never do that. You import the things you need. So here I'm going to say from pen called wizardry, that thing I wrote over here, just import turn into a wizard, that function I wrote. So I don't need everything, just give me the turn into a wizard function. And then that will be in this piece of code as though I wrote the turn into a wizard function here. It knows what that is now. So then if I create a little HSMA class in this piece of code here, I'm going to create a new HSMA called Gandalf, and I'm going to store it as an object called my promising HSMA, and I'm going to turn Gandalf into a wizard. So I can call the turn into a wizard function. I'll pass in my promising HSMA, and Gandalf is now a wizard. But we haven't defined this turn into a wizard function in this piece of code. This is a separate file. We've imported it from over here. So it saves us having to rewrite stuff. It's really useful. And this goes back to what I was saying earlier when we were talking about the first exercise. And I was saying think about structuring your functions to be as specific and simple as possible, because that will make them more reusable. Because that means you can then use that simple function. So your prime checker function you did this morning, there may be another place where if you've written it just that it takes in a number and works out whether it's prime or not and spits it back out, there may be loads of other code, pieces of code. You could import that function then and say, yeah, just save me rewriting that. I'll import that and I'll use that because I need to check whether something's a prime number or not. Okay. Let's stop there. Let's stop for lunch. So we've overrun a little bit. I think it's important you've still got an hour. We've got plenty of buffer in this afternoon, so we'll still manage to finish on time. So we'll break down to 1:40, and then we'll come back. And this afternoon we're going to look at plotting using MatPlotLib. MatPlotLib is lovely to use. Well, to an extent, it's much simpler than what you've done this morning. So you'll get to see how to do some nice graphs, and then we're going to take on my debugging challenge after that. So have a break now. Feel free to stay on the call if you want. Just make sure you're muted and your video's off, and we'll resume at 1:40. Hi everyone, welcome back. Sorry, I'm just finishing off my lunch. Okay. Just check. Yeah, it's fine. Okay, so this afternoon we're going to be talking about two things. First is going to be MatPlotLib, so plotting using probably the most commonly used plotting library in Python, MatPlotLib. This is lovely. Every year people always struggle a bit with the object-oriented program. I have to say I was really impressed with you all this morning. I thought you got that much better than I thought you would, because it is a hard thing to do. So that's really good. But nonetheless, there's always a bit of a relief in the afternoon session of the third Python training day, because MatPlotLib will seem an absolute doddle now after what you did this morning, and you'll get out some nice graphs and stuff. I say that, and I'm also conscious that a number of you have had issues when you're upgrading Spider with MatPlotLib, so we'll see if the technical issues present rear any heads. Just to flag up, if you haven't already, if you were one of the people that had to upgrade Spider, and you haven't tried MatPlotLib since, you might find when you go to do the exercise that you get an error saying there's no such module as MatPlotLib. If you get that, you need to pip install MatPlotLib and then try it again, and that should work. But a few people have had that issue. But just to let you know, I think most people have done that where they needed to. Okay, let me share my screen. Where are we? Okay, lunch break, we've had that. So let's talk about MatPlotLib. Bring that up. Why has that not worked? Sorry. Again. There we go, that's better. Right, so if we're going to be building models or doing, frankly, anything data sciencey in Python, we're probably going to want to, in some way, visualize our results, visualize our data, the results of our analysis, the results of our model, whatever it may be. Now, you could, of course, export the data from your model or whatever it is you're doing and plot it elsewhere. If you want to do that, that'd be fine. Please don't export it into Excel and then use Excel graphs, though, because what I'm about to show you is much nicer than that. And you'll find. So I would only recommend exporting if you've got a nice sort of plotting package that you use, a dedicated thing. But Python's actually got a really nice built-in library. I say built into the Anaconda distribution for plotting. Now, one of the most widely used is MatPlotLib, which is what we're going to show you today. So MatPlotLib is it's brilliant and it's really widely used, but because it is so widely used, traditionally there have been lots of different ways of doing the same thing in MatPlotLib, which in some ways is great because it means, you know, there's multiple sort of approaches to the same problem, but it also means that it can be a bit of a nightmare to learn, because you may you know, think, oh, I just need to remind myself how I set up the you know, bar chart or whatever, and then you go on and you search on the internet and you go, hang on, that doesn't look anything like I remember. That's not what I did, but it works. And it's because there's lots and lots of different ways of doing things. Since, well, the last couple of years, really, at least, MatPlotLib's developers are now recommending the exclusive use of the object-oriented way of doing things. And don't worry, that doesn't involve all of the complexity that you did this morning. You don't have to write the class definitions or anything like that, but you're going to use it in a kind of you set up graphs as objects, basically. It's actually much neater, and this is the official way of doing it now, the official recommended way of doing it. So some of you may have used MatPlotLib before and not done it this way. This is the official guidance from so this is the way we're going to teach you. I also flag it up because for most of you, you won't have used it before, but you might then go on to Stack Overflow and look and think, that's nothing like what Dan told us to do. In fact, you may even see remnants of it in this course. There may be aspects that other trainers in their content have put in based on the way they used to do things. So just be aware of that. But anything that I'm delivering should be using this format. So as with any package that we want to use, we should all know now that the first thing we need to do is import it into our code. So we're going to import MatPlotLib. Now, just as with pandas and NumPy, it's you remember we used what we call an alias, an import alias, when we imported those. So when we import pandas, we import it as PD, so we can refer to pandas as PD, and we import NumPy as NP. And those are conventions that are used. MatPlotLib has the same thing. So basically, as well as import NumPy as NP and import pandas as PD, the third line that will nearly go in pretty much everything you ever write, if you're doing data science, will be this one: import matplotlib.pyplot as PLT. You can pretty much copy and paste those every time, because you will tend to need all three for most of the stuff that you will end up doing. And basically, the .pyplot gives it a MATLAB style plotting interface. Don't worry about the details of that. Okay, so once we've imported it, let's talk about how MatPlotLib works in the recommended object-oriented way of doing things. So there's basically two objects in a MatPlotLib graph. There's a figure object, and the figure holds the graph. It's like the plotting area, essentially. And then you've got an axes object, and an axes object is a subplot within a figure. Now, most of the time, for the sort of stuff you'll be doing, you'll just have one axes object. You might have multiple plots on the same graph, but you'll probably only have one graph within the figure. So if you think about what an axes object is, imagine you might be reading a report or a paper or something, and you see a couple of figures side by side, or maybe there's a figure where you've got, you know, 4 graphs all in one figure, one in each corner. That would be one figure with multiple axes, and each of those graphs would be an axis, essentially. So if you've got a side by side or 4 in one figure, you'd need multiple axes objects. Most of the stuff you'll do, certainly in the training, you will typically only use one axis and one figure. So you'll set up a figure which will hold the graph, and then the axes for the graph itself, and you'll probably only use one for this sort of stuff. But just be aware that you can do more than one. In fact, I'm just thinking there might be in the machine learning, some of Mike's code might set up more than one. I think it does. In fact, it does. I was just looking at that yesterday. I knew there was something. So you will see an example when we come onto the synthetic data, if not before, where you see example, you've got 4 graphs set up in each one. But basically, this is what you'll do. Now, that might sound complicated. Believe me, it's not. Let's start by plotting a really basic line plot. Okay, so let's imagine we've got we've got import statement first. Let's imagine we're just going to plot 2 lists of data. So this is all this is. We've got a list called X and a list called Y. Here are the X values 1 to 10. Here are the Y values 3, 7, 2, 1, etc. Okay, we just want to plot X against Y. That's all we want to do. I'm going to plot it as a line plot. The first thing I do is I create my figure object and an axes object. And I add the axes object as a subplot of the figure object. You don't really need to worry about that too much. Basically, what you need to know is you have a figure object. I'm just going to call mine figure 1. Use a comma. And then, so the reason we're using a comma here is because, and this question was asked when we did functions about returning multiple outputs. If so far in functions, you've only seen you return one thing. And I also mentioned probably for a lot of the functions you'll be writing, if you had to return like multiple values, you'd probably return it as a list of values or something like that. But there are certain circumstances where you're returning separate things. So there are like 2 returns from a function, or 2 things that are created. So the MatPlotLib.pyplot, which is PLT, .subplots function will create a figure object and an axes object. So it creates 2 things. So we put the comma in to say there's going to be, when we run this, there's going to be 2 things that come out. Okay, so that's what we've got here. We've got a figure object. I've just called mine figure 1. You can call it anything. And an axes object. Again, I've called mine AX. You can call it anything you like. But that line of code, you'll pretty much write every time. And certainly if you've just got, one graph in a figure, which is most of what you'll do, then that's all you need. Then all we need to do to plot our data is we call the plot method on the axes object. Remember, the figure is just the kind of holding space. It's like the space on the page to put something, and the axes object is the graph. So all we do is we call the plot method of the axes object. That will create a line graph. .plot creates a line graph, and we just tell it what to plot on the x-axis and what to plot on the y-axis, which in this case I've conveniently called 2 lists X and Y. So I'm going to plot that list against that list. And then all I need to do is to tell it to show it. So I call that on the figure object. I say figure1.show, and it says, show me everything I've plotted. And that's it. That's literally all you do. So you import the library. You've got your data, which you're probably, here I've created the data, but if you're doing it from a model, for example, your model will output the results. So you're not having to create them. You just set up your figure and your axes objects, plot it and show it. That's it. That's all you need to do. But of course, you might want to put on some extra bells and whistles. Like it might be quite nice, for example, to have a graph that at least has some labels on the axes. That might be a little bit more informative than some blank labels with numbers on them. Fortunately, that's really easy to do too. So here I've got exactly the same code as I had before. But after I've set up the figure and the axes objects, and before I plot it, I'm going to set the axis labels. So the x-axis label and the y-axis label. And all I do is I call the set x label and set y label functions of the axes object. Okay, so just say ax.setX label, and I pass into that whatever I want to put on the x-axis. Set y label, same thing for the y-axis. That's all you do. That's all I've added. 2 little lines there. Now we've got the same graph, but with labeled axes. Not to be confused with the axes object, of course. That's a little bit confusing. I might object to the fact that this is a fairly standard dull blue line that's been generated. It might make me think of Microsoft, and maybe I don't like that. So maybe I want to change the color, and maybe the style. I'm feeling quite maverick. I want to change the style of my line. Who wants just a normal sort of solid line when you can have a dotted line, for example? Well, you can do that really easily as well. So after I've set up my figure and axes objects, I've put on my labels on my my x-axis and my y-axis. When I then plot the data, so remember before we had plot, we used the plot function and we just said plot x against y. Remember, plot creates a line graph. Here I'm just going to pass in a couple of extra arguments. So this actually ties in quite neatly to the one of the questions asked before lunch about what do you do, you know, does everything always have to be in the same order when you pass information into an object, but or in this case a function? And the answer is no. You can have it so that you can have lots of different optional arguments. So essentially these, we didn't have to specify the color or the line style. We didn't back there. The minimum that you need to plot is, or the minimum you need to pass in is an X against a Y, because it needs to know that to plot a line graph. But there's lots of extra things that you can pass in here, and we can denote those by giving the name of the variable, and then say equals, and then the value. Now you don't have to remember all these. There's documentation on it, and I'll show you the cheat sheet which you've been supplied with as well, which will give you all of these things, so you can set up your own and do lots of different styles and colors. So I'm going to set mine to a color red. Note the spelling. It is uses the American spelling as most things coding based do. So be aware of that. I'm going to set this to color equals red. And again, the cheat sheet will show you all the different colors you can have. Google is also your friend. There's lots of information about what the colors are. And you can be very specific. You can, give the exact shade of the red that you want. There's millions of colors that you can use. And you can also specify the line style. So by default, it'll be a solid line. But I can put in these two dashes, and that will give me a dashed line like this. So I put that in when I call the plot method. So again, ignoring the data, which you would already have, in 3, 4, 5 lines of code, I've created that. That's pretty impressive. Now, you might also want to plot multiple plots within the same graph. You might want to have one plot for something and then one plot for another thing, and because you want to compare them on the same scale. You can do that really easily with MatPlotLib too. So let's imagine here we've got, let's make it a bit more meaningful. So we've got some data here. I've got time, just values of 1 to 10 that will be on the x-axis. And then I've got a list of number of patients in the clinic and number of doctors in the clinic over time. So we might want to plot over time how many patients are in the clinic versus how many doctors. Okay, that may well be something you'd want to do for some of your models, for example. So again, exactly the same. We set up our figure and axes objects using the plt.subplots method. I'm going to set my x-axis and y-axis labels. In this case, I've got it time and versus number in clinic. So we're going to plot in the same way as we did before. So I'll plot the patients first. I call the plot method of the axes object. I want to plot time against patients. So that one against that one. I'm going to have a color blue. I don't actually need to specify the color blue because the default will be blue. But if you're going to have multiple plots, it's good practice to do that so that people can see very clearly what the colors will be. And then I'll just have the line style again. The single dash just means it's solid, which would be the default. But because I'm going to have different lines with different styles and colors, then I'll manually specify here. Also makes it easier for me to change it if I want to. So that's exactly as you've seen it before. Well, what if I, on the same graph, also want to plot doctors against time? It's easy. Just write exactly the same thing again, only this time, but doctors instead of patients. You just call the plot method again on the same axes object, and it'll tell it to do another plot on that axes object. Remember, the axes object is the graph. So just call the plot method again, and this time I'm going to plot time against doctors. And that's going to be a red line, and I'm going to use the colon here to indicate I wanted a dotted line. And then I show it. That's it. That's all we need to do. If we want to get really fancy, we might want a legend as well. So can we add a legend? Of course we can. And of course it's easy because it's MatPlotLib. So all we need to do to create a legend, well, there's 2 things we need to do. First of all, we need to, if we're having a legend, we need to tell it we need to give a name, a label to each plot. So we've got 2 plots here. So essentially what the legend is there to do is to tell us which plot represents what. So we can add into our plot method where we plot each one what the label is as an extra little argument that we pass in here. So if I say label equals patients, then that will be labeled as patients. And for the doctors plot, I'll do the same, but I'll call it doctors. So we add that into the plotting method, and then we can create a legend simply by calling the legend method of the axes object. We do that after we've plotted. Okay, so the order matters for some of this stuff. So here I'm setting up the objects, then I set the axis labels, then I plot the graph, then I set up the legend. And of course you have to do that after, because if you did it before, it doesn't know what the labels are, it doesn't know what the plots are yet. So the order does matter for some of this stuff, actually for most of it. And all I pass in a location. I think there is a default, it might be upper right. If you don't pass one in, I can't remember, but it's probably good practice to always put that in so you know where the legends are going to be. I think there are methods that will allow you to auto, in fact the default might be that it auto moves itself depending on the plot, but I might be wrong, so it'll say on the cheat sheet. So here I'm going to specify I want it in the upper left, and that's it. And then I just show it as normal. I'll come back to that bottom line in a second. So this actually, if you want to do a line plot, this probably has got most of the elements in it. You set up the objects, got some labels, you plot the data with different styles, different labels, and you put a legend on, and that will do you for most line plots. So this is pretty much how you do it. But of course, it's not just line plots. There are lots of different plots that you can have. We could do a bar chart. Okay. So again, same principle, imported the library. I've got a couple of, this is my data I'm going to plot. So I've got a couple of lists. So I've got HSMA trainers in one list, Dan, Kerry, Sean, Tom, and Lucas. This is from last year. And hours of teaching. This was primarily to make everyone else feel bad that I was doing far more teaching than them. So this is 93, 6, 21, 9, and 3. You can see now why we had to recruit Elliot, because Kerry, Sean, Tom, and Luca are not teaching this year. So this would have been a rather skewed bar chart had we not brought Elliot on board. And there's no way I'm teaching R. It's got too many funny arrows. So here's my data. I've got these. This is with my x-axis, and then I'm going to plot the numbers on the y-axis. So again, set up my plot exactly as I did before. Set up my figure and axes objects. I'm going to set my x and y axis labels exactly as I did before. That's all exactly the same. But this time, instead of calling ax.plot for a line graph, I'm going to call ax.bar for a bar chart. It's quite nicely named. And again, I'll just pass in the data onto plot. X-axis first, and then the y-axis second. And there we go. I'll show it. And of course, there's lots of different options, and in the cheat sheet I'll show you in a moment, you'll see there's different options you can set for a bar chart as well. Might want to do a scatter plot, why not? Again, same principle, import. You've got your data, set up your figure and axes objects, set up your X and Y labels for your X and Y axis. And to do a scatter plot, we just use ax.scatter and give the X and Y values. So there's lots, and there's far more than those, but those are some of the common ones. Line graphs and scatter plots are ones that you'll use particularly often, and possibly bar charts for some of your results for a lot of the stuff that you'll be doing. You'll see lots of examples of those in the machine learning, for example, and so they're particularly the scatter graphs and the line graphs. But as I say, there's plenty more. Google is your friend, frankly, but there is a MatPlotLib cheat sheet, which you can access online. You can just Google for it, or we've supplied it in with the materials for today. And so you can use that. And if you have a look at that, it gives you lots of different things. You can see there's, as well as plot, scatter, and bar, there's contour plots and pie charts and all sorts of things that you can do. And it shows you the different options that you can have, different scales. It's a really neat little cheat sheet. And it's even got, you know, how do I do various things and where the legend will be placed depending on what you need to type in to get it there. So that's your friend. That will help you. And you can see all the millions of potential colors combinations that you can have as well. I'd also recommend that you check out, so a plug here for my colleague Tom. He's got some fantastic MatPlotLib tutorials here that will go into this in much more detail. I'm just showing you the basics really today and getting you to have a bit of a play around with it. But he goes through and walks you through some nice examples in some Jupyter notebooks. So in fact, let me just click on that. So here's the first one, goes through some of the initial stuff that I did, but then shows you some walked examples of how you can do this. Really nice style, so you can very easily follow along with that. And the second one then goes into some more advanced stuff. Now, it's also really easy because probably if we've got some graphs, some nice graphs we've created, we probably want to use them again later. So there's different ways you could do that. You can just copy and paste them if you wanted to. You can right-click copy. Remember in Spider, if you're using Spider for this, they will come in the Plots tab. I have heard from a couple of people that in the upgraded Spider, they might appear as a separate window. So just be aware that might happen. It doesn't on mine, but it might happen. I'm still on an old Spider. So you could just right click on them and click copy and paste them somewhere else. Or a better way of doing it, you can save them. Now, if you're in something like Spider, there is actually an option at the top of the plots window where you can just click save or copy and it'll do those things for you. But you can also do that in the code, and probably that's the way you'd want to do it, that you'd have your code maybe run your model, it would calculate the results, then plot the results for you, and then automatically save them. So you've got the plots then saved. And it's, as you might imagine, it's really easy to do that in MatPlotLib. We just call the savefig method of the figure object. So here my figure object is figure 1. So I just call .savefig, and then I just pass in whatever I want to call it, and it will save it in that directory. I can put in, and if I want to put it in a subfolder, you could put it plots stroke whatever it might be, and it will save it in a folder called plots, etc. if you wanted to do that as well. It's really easy to do that, single line of code. Okay, so pretty straightforward. So I'm going to give you this exercise to do now. This, I think, is probably, you had the hardest exercise this morning. I'd say this is maybe the easiest. I'm hoping it will be, and apologies if you do struggle, but I think you'll hopefully this is much nicer and much friendlier than what you had this morning. So I want you to write some code that plots a line plot comparison of hospital A and B mean ED attendances per day of week. In other words, this data in this table here. And I want you to use different colors, styles, and a legend to clearly differentiate the two lines on the plot and label each axis appropriately. Now, just to, because I want to be a little bit mean, because that might be a little bit too straightforward. So I'm also going to ask you to force start the y-axis, because these are all high numbers. And by default, it won't then start the y-axis at 0, because the scale would be, there'd be a lot of white space basically. But I want you to do that. So I want you to force start so that the y-axis will start at 0. You might want to try it without it first, and then see the difference. Now, to do that, you can use something called the set ylim method of the axes object, and you pass into that y_min equals 0 as a parameter. And what that will do is it will force the y-axis to start at 0, regardless of the scale of the numbers that it sees. Now, important note, this very much is important where you place this. You have to do it after you plot the data, not before, but before you show the figure. So after you've plotted the data, like with the legend, you have to do it after. If you don't, it won't resize to the data, because essentially you're plotting the data and then it says, okay, well, I would scale it between 300 and 600. And then you're saying, no, I want it scaled from 0. So you have to do it there, otherwise it won't work. Once you've done that, I then want you to set up a new figure that plots on a bar chart the total mean ED attendances across both hospitals by day of week. So what I mean by that is plot the total for Monday versus the total for Tuesday versus the total for Wednesday across both hospitals. That's obviously a fairly meaningless figure, but it's just to get you using a bar chart. So add those numbers together and plot that for Monday, etc. So I'm going to give you half an hour and take a 10-minute break there as well. If I suspect most of you will do this fairly, how are we doing for time? Yeah, well, I expect most of you will do it fairly quickly. In fact, if you finish really quickly, I might bring us back a bit earlier. But let's give you about half an hour. Give you a bit of time to stretch your legs for the next bit. But also, if you do finish this early, have a look at the cheat sheet and try out some other things. Try out some other charts, make up your own data, have a bit of a play around with MatPlotLib for the next half an hour, basically, and get to love it because it's really nice and easy to use, and you'll be using it a lot. Okay, I will open up the breakout rooms now, and we'll float around. As I say, make sure you're doing what you did this morning. It's been fantastic today to see you all working nicely in your groups, and it's made such a difference, because from our perspective we can see, you know, where people are struggling, where people are getting it, etc., and that really helps us. But it also means people aren't struggling in silence, which is really important that we don't do that. So fantastic to see you're working. So carry on doing that. You're doing some great work today. Okay, I'll open up the rooms now.
This meeting is being recorded.
Hi everyone. Okay, you did that really quickly, so well done. That's I'm gonna take a bet that you all really like MatPlotLib now. It's a good way to get you to like MatPlotLib, because we put it on after object-oriented programming, and it's so easy compared to that. So I'm sure you'll all be loving this thing, which is good, because it's an important tool. So fantastic, great to see so many nice graphs, and because of that, you've earned the prize of now having one of you volunteer to show us what you did and talk us through the code, because it'll be much nicer, I'm sure, than mine. So it's time, I think, to get out the wheel of names. So we haven't spun that today, so let's give it a spin. I've already given it a shuffle. Let's see who's gonna be the lucky volunteer today. I think it's probably going to be Amstrad. Yeah, it's going to be Amstrad CPC. Does somebody from that group want to talk us through your code?
I can probably do this.
Awesome, thank you.
Can you all see my screen?
Yeah, that's come up great.
So it's pretty basic, but we are importing MatPlotLib and also NumPy, simply because we wanted to quickly calculate the mean between the two data series. So again, there's probably a more elegant way of doing this than just copying and pasting from the PDF or manually typing in. Simply defining the first plot. So we are setting the labels for both axes, some very basic formatting, defining where we want the legend, set the limit as you told us to do, just to avoid the scale of the x-axis being cropped, just showing the figure. And then what we're doing is essentially is some basic manipulations so that we can calculate the mean across the data points for the two data series, and then use this as a data series to plot an additional plot, essentially, a column chart.
Fantastic. Thank you. That was great. What I really like there is that you've thought about how that might be made more efficient. You've actually used NumPy, which is actually, so I didn't need you to do that. In fact, the solution doesn't, and just goes through a for loop, which I suspect many of you will have done. I really like you thought, actually, thinking back to the NumPy stuff we did last week, that actually that's a more efficient way than going through a loop to easily add two things together. So that's a really nice solution. Obviously for this, it will, you know, it's seconds, sorry, sort of nanoseconds of difference, I suspect, between the two. But you could imagine if you were doing this for thousands of hospitals over 3 years of data, that going through a for loop and then adding everything together would be then quite inefficient. So really well done. That's really nice that you've thought about how to make that more efficient. So that's a really nice solution. Fantastic, brilliant. I like you've made the plots green as well. I like that.
Team effort. Thank you.
Yes, absolutely, brilliant. Well done. Okay, so let's move on to the final bit today. This is what you're going to be spending the rest of the afternoon, and indeed the rest of your coding life, pretty much doing, and that is debugging. And I've got possibly one of my favorite exercises coming up this afternoon. Favorite for me because I get to watch you all cursing my name and gradually hating me over the course of about an hour-long exercise. So debugging. Now you will find, as you probably have already kind of experienced already, that you are, as you code more and more, and as you code more and more complex things, you'll spend an increasing amount of your time trying to fix problems. Now, it's important to reiterate at this point, that does not mean you're bad coders. That means you are coders. That's what we do. You spend huge amounts of time trying to work out what on earth has gone wrong in your code. Okay, that's normal, completely normal, and that will happen. People that have been coding for 30, 40 years will still be doing this as a big portion of their time. It's a thing. And this process of trying to fix problems in your code is known as debugging, and it would be remiss if we didn't in some way cover it in your coding training, because it is so fundamental to what you've been doing. Now, the Python interpreter will try and help you out, and indeed, depending on your IDE, you'll see in Spider's a bit more helpful than things like Jupyter. In that it'll flag things up saying, "Are you sure you meant that? I don't think that's right," or put a little red cross. "I don't really understand that line, just to warn you. I'll let you run it, but I'm probably going to fall over at that point." And I believe VS Code has a really nice thing. So if you get a good IDE, then it'll help, but it won't solve everything. There will still be stuff that you've missed. The syntax errors are easier to diagnose, but some of the other stuff is not. Now, the Python interpreter, when it goes through and tries to run the instructions that you've given it, will try to help you as well. The usefulness of that help can vary between, "Oh, thank you, yeah, that's exactly what I needed," to "I have absolutely no idea what you're talking about." So it can be a bit tricky. So let's have a look at some examples, and I'm going to ask people just to shout them out as soon as they think they know what it is. So I'm going to ask you what you think has gone wrong here. We've got this piece of code here, and it's thrown up this error: "Can't multiply sequence by non-int of type string."
You need to cast as integer on those numbers.
Exactly so. Yeah. So we've taken an input here, and then we've tried to do a mathematical operation on them, which we can't do with strings. So we need to cast an int. So that's a nice easy one to start with. Believe me, that will be a common one. If you're getting user input, you will forget to do it. That's worth knowing. Okay, so what do we think has happened here? It says list index out of range.
It's the 0 index. It should be 2.
Exactly so. Yeah. So, and again, something particularly when you're starting out in coding that you will forget is that it should start at 0. So therefore, the third element is actually number 2. I find you'll forget it more. It's less a problem when you're doing it as a single reference, where you're doing a slice where you're slicing out numbers. That for some reason, it's certainly in my head, it gets harder to think about. So be aware of that. That's quite a common one. Again, you'll see. Okay, so we've got this piece of code here, and we've got name wait time int is not defined. What do we think's happened here?
You're referencing on line 5 into wait time int, which hasn't actually been defined yet.
Yes, well done. So they're a little bit more complex. So it's deliberately made this so they're not fantastic variable names, and they're a bit complicated, which actually indicates why you should name your variables nicely. But yeah, what we're doing here, we should be grabbing in some inputs and then casting them here as integers and storing them as the integer variable. We've obviously made some sort of typo here, and that should be wait time string over here, but we haven't done that. But the consequence of that is that what this line of code is actually now saying is I want wait time int to be an integer version of wait time int, but you haven't created wait time int. So you've told Python this new thing, I want it to be the integer version of this new thing. Well, it doesn't know what the new thing is, so that's why it's fallen over. So the actual problem here is, oh, I should have put wait time string. That's a typo. So sometimes you've got to do a little bit of detective work to work out, because technically the error is, well, I don't know what wait time int is. And if you look at that first, you might think, well, I've just told you it's here. But yes, sometimes it needs a bit of digging around, but it will at least get you to the point of thinking there's something going wrong in that bit. Okay, what's happened here?
Double equals.
Yeah, again, another common one. Especially when you're starting out with Python, that you forget that a single equals does not mean equals. It means assignment. It means this thing should be assigned this thing. So if two things are equal, they need to be double equals. I always find, I've done this for years in my head, I always think of equals in that sense as being strictly equal. And then that sort of double, those two words help me put in the two equals most of the time. Okay, what's happened here?
I would guess given the method of the bottom brackets.
you would guess correctly, yes. People often sort of try and furiously count the brackets. Yes, your instincts are spot on. This is again a good warning about using lots of nested brackets, because you will very quickly find that it gets into a mess, and you can't remember where you are. Now, again, a good ID like Spider will show you. You've probably already seen it when you close the bracket. It'll sort of color code them and show you the corresponding bracket that you're closing, but it's still not foolproof, and you will trip up if you're not careful. You have to pay attention. So yeah, that's it's simple invalid syntax, which is basically just Python's way of saying you've written something that doesn't make any sense. That's invalid syntax. Okay, what do we think's happened here?
Is it that there's nothing in the else? I don't think you need that if there is no else.
Yes, spot on. So, and this one can trip people up, especially when they're creating code and they're quite new. And I've seen a lot of people do this in HSMA over the years. I've even done it myself, forgetting about it. They'll often think, well, okay, and it's a good tactic. You kind of break things down, and you think, well, I'll just write the if bit and see if that works first before I write the else bit. And you might think, okay, well, I'll need to put something in there. I'll just put a little comment that says, you know, do nothing, or come back to this later. I've seen as well. And you might think that's enough. It's not. Python ignores comments, so it's not even reading that. So as far as Python is concerned, you've written an if statement, which is fine, but you've then told it, but I need you to do something else if that isn't true. But then you've not told it what to do. So Python will then come up with this message, which is unexpected EOF, which stands for end of file. So while parsing, so it's basically said, I was expecting you to say something else. You've stopped. It's like you've stopped mid-sentence. You're about to say something, and I need to know what it is. But I've reached the end of the file. So what was it? You're supposed to say something. So be cautious. That's particularly when you're trying things out. That can be so you can if you want to do this, because it's quite a good approach. If you want to, you know, just test a bit of your code, a bit of your if statement, you don't want to write the else bit yet, but you want to put in the structure of it. You can use the keyword pass, and that basically just means do nothing, but Python will read it as an instruction and execute do nothing, and it's enough for Python to say, okay, I won't do anything. Obviously, if you shouldn't, if you were intending to do nothing, then you don't actually need the else there in the first place. But this usually crops up where people have, particularly in exercises in the HSMA program, where you're think, right, okay, let's just get the if statement working, this bit, before we move on to the else, which is a good approach. But putting in a comment or nothing at all will not work. You will get this error. Okay, what about this one? This is a bit trickier. There is a clue, but it's a bit misleading.
Do you need two positional arguments, name speciality for start teaching?
You need to actually instantiate.
Yes,
Yeah.
instantiation is the problem. So this is why it can be a bit misleading. Basically, what you've done here is you've created a new class called Pencordium. We've set up the constructor here. We said that, and to create a new Pencordium, we need a name and a specialty. And we've got a method of a Pencordium, which is to start teaching, and that takes in a subject. Now, normally what we should do is then we don't reference the class directly. We create an instance of the class, an object, as we talked about this morning, and then we call if we wanted to get them to start teaching, we'd call the start teaching method of that object. But you can directly reference things in the class. In fact, when we come on to the object-oriented SymPy, you'll see there's an example of that where you actually have a class that you reference directly. You don't create an instance of it, and it's basically there to hold your global variables. And it's one of the few situations where you don't actually create, I think it's just like a holding pen. Now, in this instance, so Python will let you do this. You can reference the start teaching method of Pencordium. The problem is, because you're now referencing the class itself, not an instance of it, it's now expecting 2 arguments, because remember, self is a copy of the object that's created at instantiation. But because you haven't created that object, it's waiting for a copy of the object. So here it's saying it's missing 1 required positional argument, and it's saying it's missing subject. That's because you passed in programming thinking it means this, but it said no. Okay, so self is programming, and now it's confused. So probably what you intended to do here was create a new Pencordian and then call the start teaching method on that. But just be aware that can be a little bit misleading. You have to do a little bit of detective work around that. Okay, great. So what we're going to do now, you can have an hour to do this, maybe a bit more, depending on how things go. So I've given you a file called debugging-challenge.py, and basically I've created a Python file. I've deliberately not put in any comments to explain what anything does, and I've got it working and then completely broken it. Okay. Your challenge is to work out what on earth this code is doing, what this program is supposed to be doing, and fix it. Now, there are a lot of errors, by my count, 53 of them in there. Some of them will stop the code from running. So if you try and run that code, as I've given it to you, it will not work. It will immediately just fall over. Okay, but you may eventually get to the point where you fixed it enough that it runs, but it's still not. It still may not work as you think it should. So you also need to work out what it's supposed to be doing, because you might find that it's this goes back to our validation versus verification, that you've verified that the model is is kind of working in that sense, but actually it's not performing the intended purpose. So you're going to need to test everything really, really thoroughly, and you're going to need to work on this as a group. So what I would advise you do, again, have one person who's sharing the screen, and you're going to need to shout out where you think the errors are and why you think they're problems. Okay, but the first thing you need to do is look through it as a group and work out what you think it's supposed to be doing. Now, this is a bit of a devious challenge because it's not particularly hard. It's just a bit of a nightmare to go through and do all this. Welcome to coding, because this is what you'll be doing for a lot of your time. Unfortunately, it's just one of those things. If it makes you feel any better, the first time I wrote this a few years back, when I first wrote this this thing, I broke it and forgot to note what I'd broken, where I'd broken it, and how I'd broken it. So then, when I was asked, I realised I had to give a solution. I had to go back and do my own debugging challenge, and it took me a while. Okay, so I had to go through and do this. So if it makes you feel better, I've been through the pain too. I had to do my own challenge in order to make a note. So I do now have the solution which notes where all the errors are. Some of them are easier to spot than others. Some of them are quite deceptive and devious. So be aware. And as I say, some of them won't throw up runtime errors. They will allow the code to run. It's just it won't be running as you think it should. So you're going to have to try and work out what it's doing. I would also advise, it might be a good idea, first of all, to put in comments as you work out what the code is supposed to be doing, because all code should have comments to explain it. And that's why I've deliberately removed them here. So try and make little notes about what you think it's doing using comments. And you may also want to make note of where you made the fixes and what you did. So you can put a little comment either on the line above or on the after the line, just saying what you fixed. And then you can, once we come back, we'll have a look at the solution. Okay, time for the annual Dan's Devious Debugging Challenge to begin. So I'll give you about an hour. We'll see how you get on. You probably need it. And I will open up the breakout rooms now.
Rich, are we allowed to ask about your?
This meeting is being recorded.
Okay, hi everyone. Welcome back. So, do you find that fun? I appreciate it's a bit of a deliberately mean task, that one. And it's to give you there's a few lessons in that particular exercise. The first is that was to get you used to debugging, which is something that you'll be spending a lot of your time doing as you're coding, and as you code more and more complex things, you need to get used to that. So getting used to the kind of clues that you're given, and trying to work out what might be going wrong from those clues is really important. The second is the importance of commenting your code. So I deliberately gave you some code with no comments whatsoever. And so I think a lot of you are struggling to work out what on earth was going on. I heard quite a few of the groups saying, he keeps saying about this list of numbers. What is this list of numbers? What's it doing? And in fact, you would have probably had to try and work out from the bottom, would have been probably the easiest way to do it, after the class definition, how these things were being used. But of course, if I'd have included comments in the code, such as this function adds up adds up a list, adds up some numbers within a list of numbers that's passed in, or something like that, obviously it would have made your job much easier. So that's a stark reminder of why you should include this kind of stuff. And the third is that it's an absolute nightmare trying to debug someone else's code, particularly if you don't know what it's supposed to be doing. They haven't commented it properly. It's one of the reasons why in the project phase, as mentors, we will not do that. We do not look over your code in that way. So it's a good skill to have, to try and be able to debug your own code and understand what's going wrong with it. And the clues are all there. It just needs depending on the IDE you use, it provides you with tools to be able to try and focus down on where you think the issue is. But all of that could have been made easier if you had sort of comments about what was supposed to be happening at various bits, because at least that way, if you've got well commented code and you say to someone else in your project team, I'm trying to get this bit working, I don't understand what's supposed to be happening, at least they get an understanding of what's supposed to be happening, and that gives you a much better head start. So if you haven't already seen it, I've posted, I'm not going to go through the solution now because it's massive, but I've posted the solution in the module 1 channel, and I've all of I still haven't included comments, but I've what it's supposed to be doing, but I have included comments to indicate where all the errors were, so you can try and find it. If you were, I think quite a few of you managed to finish. Hopefully you managed to get it working, although even if you got it running, as I say, you may not have got to the stage where it was actually working as intended, so it's worth thoroughly checking that. But if you think you did, then do have a look, if you haven't already, at the solution, see how much of it you picked up. Did you miss anything? If you were still working through it, then you might be worth going back to it and seeing if you can finish that off before looking at the solution, to see how much more you can find, because it's quite a useful way. What was really nice is that going around all the groups, I could see that you were saying, oh yeah, I think that's supposed to have a double equals there, or yeah, we're missing a return statement. That's all the kind of stuff that we've covered, and I deliberately wrote the code to cover a lot of the stuff that we've done over the last few weeks, to get you used to, if you can find where things are going wrong, it'll help you understand how to code in this way. So the solution's up there, so do check that out in your own time. I'm sure you all probably worked out that it was a calculator, and it was called calculator, which helped, but that it was supposed to be doing these various operations, and you'd give it commands, and it would take in lists of inputs and deal with those. Not particularly efficient piece of code, deliberately so, and this isn't how you'd actually create a calculator by any means, but a way to give you I wanted to give you lots and lots, hundreds of lines of code that you'd have to try and work out what on earth it's doing. So hopefully achieved that objective. Okay, so what we're going to do now, just for the sort of closing bit, so over the last few weeks, we've covered, a couple of weeks ago, we covered all of the fundamental stuff in Python, all the things from variables and inputs and outputs and loops and all the conditional logic and all that kind of key stuff. Then last week, we moved on to talk much more about functions and exception handling, and we introduced a little bit of the basics, and nothing more really, of NumPy and pandas, and these are things that you will, NumPy and pandas in particular, you will get a lot more use of throughout the training. And obviously today we focused in on the object-oriented programming this morning, and the nice MatPlotLib stuff this afternoon. Now, this by all means doesn't cover anything near everything that Python does. Of course it doesn't. The idea is to give you the kind of basics, the basic building blocks that you're going to be using and building upon as we move into the rest of the course. Because of course this course is entirely focused, is not a course to teach you Python, although that's one of the benefits, but it's there to teach you the basics in Python to allow you to be able to build models and to do all this data science stuff that we're going to teach you from next week onwards. So next week we're going to be moving into discrete event simulation, onto machine learning, and then throughout the next 5 months into all these other methods. And throughout all of that, you'll be introduced to some additional concepts. So next week, for example, as part of the SymPy training, I'll show you, so we'll talk in the morning about discrete event simulation again, and go into much more detail about what it means to build a discrete event simulation. Then we'll show you SymPy and how you can build that in Python, using that Python package. But we'll introduce a new concept of a generator function, for example, which is something we haven't yet encountered, which is a bit like a function, but works a little bit differently. And so you'll encounter lots of these things. There'll be little things called lambda functions that you'll encounter later in the course, which are these weird little sort of disposable functions that you use very quickly and then you chuck them away. So there's lots of little things that you'll gradually learn. So it is by no means the end of your Python coding journeys, and you'll get to practice all the skills plus learn some new more as we go through the various methods that we're going to show you. My overall advice for any of this, as I've been sort of saying throughout, is that you should keep practicing coding. So practicing coding is the most important thing you can do to learn code. That's by far the most useful thing you can do. Just write little bits of code, even if it's 5 or 10 minutes here and there. That will help you a lot. And as we come on to the various methods, practicing some of those skills after the sessions will really help you. And you will get lots of practice in all of these basic skills as we go throughout the rest of the training. Now, obviously from next week, we are opening up the alternative stream, the revision session stream that Elliot's going to be leading for 3 weeks on a Wednesday. Now, hopefully you've all seen the posts about that. My advice for that, so if you're wondering about whether you should fall into that camp or not, I guess my general advice would be, if at this stage you're feeling like you kind of got the gist of it, you might need to refer back to the notes to remember how certain things work. That's completely normal. That's where you pretty much expect to be at this stage. I know what an if statement does. I might need to look up to remember if you put in a colon or something there. That's fine. If you're in the camp of if you told me to write an if statement, I wouldn't know where to start, then that's where I'd probably advise you move into the revision sessions, because what we don't want you to do is to drown when from next week we start showing you all this fancy stuff you can do, and you think I'm still really getting the basics of Python. So Elliot's 3 weeks of sessions will basically essentially go back through these last 3 weeks. But rather than me teaching in a kind of lecture style to 100 of you, Elliot will be able to sort of go back through and work with you in a more sort of one-to-one way with a smaller group. So I don't want you feeling as though you, if you're not, if I told you to go off and write something without looking anything up, that you don't need to be at that stage. In fact, none of us are at that stage. I still have to remind myself of things to do. I can't remember, which way around things go. That's completely normal. But if you find that you are struggling a bit more, and that you're not really comfortable with a lot of the stuff that we've covered, then Elliot sessions will be able to help on that. So that will start from next Wednesday. So they will run parallel to the main sessions. We'll have the main training on each Tuesday, but then for 3 weeks, so starting from next Wednesday, you can choose. Now you can, as I did post on Slack, if you wish, you can come along to both, but I'm conscious that 2 days out of the week might be, for 3 weeks might be not doable for a lot of you. And also, even if it were practical, you might find that you would then struggle. And I don't want you feeling as though you're sort of drowning when we do the Tuesday session. You think, I still don't understand the Python basics enough to be able to do this. So I put on some advice on Slack, which if you haven't read, I'd give it a read, about if you want to duck out of the main training for those 3 weeks to get back up to speed with Python, some advice about how you can sort of reintegrate into the training after, because it will require a bit of catching up, but all of the modules are pretty much standalone, so you can sort of drop back into other stuff. And we've got a nice period off over Christmas, extended period, where you can potentially catch up on some of the other stuff. I'm very conscious that the machine learning stuff in particular is probably the hardest module that you're going to be encountering. It is designed to be fairly gentle because of that, so don't panic. I do take you through things gradually, but in terms of Python skills, it is the largest leap. You know, in what, 4 weeks time, I think you will be writing neural networks, and they're not as scary as they sound. But if you feel completely sort of lost with Python, then you might want to take advantage of the revision sessions first rather than sort of drowning further. So I suspect that for most of you, you're in the position of I think I'm getting the gist of it. You know, and you're probably in the right sort of area. But if you're finding that you just don't think you're getting any of this at the moment, then do take advantage of Elliot's sessions. Now, I did wonder, just for the closing parts, normally what we do here is have a bit of a sort of Q&A session on, you know, is the stuff that you'd want us to go back over. I think in light of the revision sessions, etc., that we're putting on, and also some of the other fantastic materials that Elliot's putting together, I thought it might be quite useful just to get a sense about if there are particular areas that you'd like sort of Elliot to focus on in those revision sessions, or areas that you'd like a little bit more practice on, because I know Elliot's doing a lot of stuff around you know, some of the NumPy and Pandas stuff that he's already put up, practice exercises, looking at doing some stuff around exception handling, which I think is a great idea, but really just get a sense if there are particular areas that you'd like to focus on, because, you know, this is really to support you, this extra support to make sure that we're focusing on the right areas. And if everybody's comfortable with if statements, then we don't need to worry about if statements. Elliot, I don't know if there's anything that you want to sort of chip into that, or anything that you're in particular thinking about, you know, sort of additional support on.
All I would say is, don't be afraid to ask for anything. There is no stupid questions, so feel free to message me privately if you don't want to say it in a group forum. Obviously, every suggestion or request I get, I'll try to weave into it. If I can come up with additional exercises, because as you've just said, Dan, practice makes perfect, I will do it that way. If it's something we can make sure we cover in more depth in those catch-up sessions, the basic premise of those would be really to follow the same kind of pattern of what was taught with Dan. So if there's things that we can speed up or drop, you know, gloss over because no one needs them, great. And if there's other things that we're going to spend more time on, well, if I know that in advance, I can make sure I have enough material, I can have enough exercises, and we can all just sit there in a group and do the exercises. And there's absolutely nothing wrong with that. The whole idea of this is to get you comfortable, and then before you know it, you will be flying. So it's not remedial or anything like that. It's just that, you know, if life has meant you've not had the opportunity to learn at the pace you usually would, here's the golden ticket to hopefully try and address that.
Yeah, no, absolutely, totally agree with that. And I think that yeah, that's absolutely really useful. And, you know, the whole point of doing this is to support you as best we can. So let's focus on the things that you need the help with, you know, and we'll try and support you as much as we can with that. And also, you know, it's like I say, it's not, you don't feel as though you have to be a Python expert at this point. But I wouldn't expect most of you to be in that position at the moment. You're going to get lots more practice, but at the same time, we are conscious that there are those of you who feel that you're struggling a bit too much and could do with that extra support, and that's what we're putting on for you essentially. So are there, I mean, I don't, people, as Elliot says, you may want to sort of message Elliot privately about things, but if anybody, I don't know if anybody wants to use this as a forum to things that you'd like to sort of go back over. I see in the chat already some stuff on the sort of while and for loops. I think that's probably a good idea. I think that I've seen some people get a little bit confused about some of that, and particularly I think, you know, for loops with some of the indexing, and that can be a little bit difficult to get your head around initially, and something as fundamental as that will be useful then sort of moving forward. Is there anything else that, I mean, feel free to shout out or put anything on there. Exception handling I see is coming up in the chat. Yeah, that's yeah, I think actually Mike put up a good thing earlier, some advice around that, which is yeah, and hopefully I made that clear in the training. You're not trying to catch everything with exception handling. It's about where you've got some sort of external input, and I mean external from you as the programmer, that you're trying to catch either direct input from the user or something, that a file that they might put in that's just not going to be in the right format or something like that, to try and catch out and make sure your program just doesn't collapse if they do something that you don't intend. That's really what exception handling is. I see. Oh yeah, so I see yeah. I meant to mention that earlier about the Git session. So hopefully you've all seen that in Slack. So right, Git. So I was going to run Git. Elliot and I had a good chat about Git last week, and I think Elliot was saying we sort of went to and fro on this a bit, and then I eventually concluded, okay, we'll do Git, but we'll kind of say on the day, stay for the first hour, and then the doors open if you need to run, because Git is a bit of a Git. Git is not a pleasant thing to use. It's a very important thing. It's all about version control, and we go through in the session why it's so important to make sure that when you're coding, that you're controlling the version, controlling how you evolve your code. But it is a bit of a nightmare, and even for experienced coders, there are entire websites dedicated to what you should do when you completely muck everything up in Git, and you will. So I came to the conclusion, I started through on Sunday evening, I started reminding myself of the 130 odd slides on Git, and I just thought, this is too much for you all at this stage. It's important, but it's not essential right now, and I'd rather you're in the position of getting more comfortable with Python and with the methods that we're going to be showing you over the next few months, than trying to get your head around this weird thing that everybody finds a bit weird, but will eventually come to you. So we've moved Git right to the end of the training phase. It'll be after the assessment, after you've put in the Python, your project ideas, after all of that, and then you can just relax a bit. And then have a go at this Git. The one good thing about Git is that pretty much everyone hates it, and so you will all come together in a kind of general, what on earth is this going on about? And I've tried to make it as friendly as possible, but it is a bit of a sod, really. So we've moved that. Let's worry about that later, and we'll take you through. But it is important, but it's not essential right now. I think it would do more harm than good to try and give you a session, on a pretty intensive session on Git at this stage. So we'll keep it relaxed, and also it means that people don't have to find a second day this week to try and spare for that, because it's not an easy one to catch up on, really. You'd need to give it some dedicated time to look at that. So there's no session this Thursday now. If you've still got that time set aside for HSMA, might be a good idea to go back over some of the materials we've gone over in the last few weeks, but otherwise we'll continue with the training on the SymPy training next Tuesday. Do have a look as well and make sure that you are, so I've put up the prep instructions for next week. From next week, you're going to have to be doing a lot more of installing packages as we go. So you'll see this marks the first, well, I say the first time, quite a few of you had to pip install NumPy and Pandas unexpectedly. But next week, for next week, you need to pip install SymPy. And going forward, you'll need to be doing some installs, some of which will be a bit more complicated. So one of the things that when Elliot gets to the geographic modeling in the new year, looking at something called GeoPandas, that's a bit of a sod to install. We've gone through the pain. I say we. Mike went through the pain last year. I then immediately gave that pain to Elliot when he joined us, and now Elliot will go through that pain for you. But it's a nasty one to install because it breaks things. So you have to be very careful about what else you install with it. And it turns out it's even worse on Windows, which you're pretty much all using. But don't worry, we've been through this process before, so we'll be able to guide you through that. But the reason I flagged that up is because up to now, the kind of prep instructions have been largely just make sure you download the files ahead of time. But from next week onwards, you need to start installing stuff. SymPy will take you a couple of minutes to install, if that. but going forward, there will be some more complex installations that you'll need to do, which hopefully you should all be able to do. It sounds like you're all okay doing the pip installs. That should all be fine. So before we close, is there anything that that people want to sort of flag off? Anything either that you want like to focus on in some of these revision sessions, or anything generally that you're not sort of clear of by this stage? Any questions? Say, Elliot's quite right. There's no silly questions whatsoever, because you're probably thinking something that everyone else is.
If no one else is asking a silly question, then can I? Because it's a really silly question.
Please do.
I've been looking. I'm still trying to get used to all the different platforms. So I use Teams, and now we're using Zoom. Or I don't use Slack, and so I'm kind of all of it is brand new. I'm used to obviously interchanging, but kind of be patient with me on this. So how do I orientate myself around Slack? So you said that the information's in there about the revision session. So I've been looking and I can't find it. And I don't know where I'm supposed to even be looking. So I then get quite frustrated and just be like, why are we using Slack? So where can I find the revision sessions? But also, can you tell me, how these are structured in the way? Because it looks like I have to look at module 1 for everything at the moment. Is that right?
No. So okay, so that's a good question. Okay, so and yeah, we haven't really sort of talked much about Slack other than some general information in the welcome email. So basically, I'm conscious a lot of you haven't. Some of you used Slack before. I know a lot of you haven't. So Slack is basically it's kind of messaging platform that is particularly good for coders, and that's how it originated. And the reason it's good is because for coders is because it's very easy to share code, and that's why we use it on the program. Now, basically, the way in which Slack works is it's separated into various channels, so you can have different kinds of chat within different channels. Now, there are quite a lot of different channels on the HSMA workspace. I can actually see more than you can because I've got all the HSMA 4 stuff as well. But basically, the key channels, so you've got a channel for each of the modules. So those modules, at the moment, there's been a lot of stuff in module 1. That's because most of the training sessions, other than one that we had on the Thursday back in the first week, were for module 1 of the program. So from next week, the SymPy sessions, that's it. That's module 3. So in your key dates file or in your calendar invites as well, you can see the session codes. Key dates files is probably the best place to look. And you can see what sessions are upcoming. So 3A and 3B are the 2 sessions next Tuesday. So the 3 indicates it's module 3, modeling pathways and queuing problems. And so anything related to that module, including the instructions, the preparation instructions, that's the key thing that goes in there. Stuff that you'll need to do ahead of those sessions will go in the relevant module channel. So module 1, other than when you come onto the R bit next year, we've nearly finished module 1 now. There's just a bit of R. The module 2 would have been finished this week because there's 2 sessions, and the second one was Git, which would have been this week, but that will now finish at the end of March. Most of the rest of the other sessions will kind of we don't go through them in order because they go all over the place, but we will do module 3. And then that's finished, and then we'll do the next module, which will be module 7, and then we'll do the next module, whichever one. I think that's natural language processing, module 8. So we tend to then do a module, do all the sessions in that module, then we move on to another module. Yeah, the stuff so far, a lot of it's been in module 1 because it's been about the module 1 sessions. But you look at the whichever module is coming up, basically. You should find as well that you get a little indication of when new messages come in there, and it will go sort of a bold font, and most of the other module channels should be empty at this stage, so that should help a bit. You've also got your peer support group channel, which you should only see one of them, which will be for your peer support group. Again, Elliot and I've got access to all 10. And that's we'd encourage you to use that. That's your primary chat channel, really, because it's where you'll be talking in a group, and even between sessions, chat in your groups. And this is last year, a lot of the cohort found it was really useful just to talk to each other, you know, sort of between sessions. If you've got questions, etc. Elliot and I can see all of it, so if there's stuff that you need, we can see it as well. But it's only us and your peer support group. So if you'd rather just talk to your group, that's a good place to do it. The HSMA tannoy is where most of the sort of general announcements are. So that's where I'd kind of put most of my stuff, which is announcements about what's happening, updates to the program, like where I put about the Git session being moved, that kind of stuff. Big announcements that are coming through the tannoy, if you like. The common room is basically like your peer support group, but for everyone. So you can all come together, and if you want to share things with the whole cohort, you can do so there. And the water cooler is there if you just want to chat about random rubbish, and please do that, because that's a good thing to do. You are a cohort, and we you know, part of the idea of the program is to work collaboratively. So if you've just seen a funny meme about coding, plug that in there. If you want to talk about any random rubbish, just put it in the water cooler and just get people talking. That's a really good thing to do. The intro videos and mini bios, don't worry about that. So the main things to look out for really. The tannoy will alert you to big announcements. The module channels for each module as we go through them will open up, but just be aware they don't go in order. So far they have largely, but after 3 it goes to 7 and then 8, and then it jumps around a bit. If you're wondering why it does that, it's because the modules are still numbered as they were 2 years ago. But then when I found I was doing all the training because none of the rest of the team could do it, we needed to recruit some people. And before we recruited Elliot, I thought the best strategy was to put all of my stuff in the first half and then worry about all the stuff that somebody else at that point unrecruited would have to do in the second half. So that's why you've got a lot of me before Christmas and then only a bit of me after Christmas. And that's why it is, and that's why the numbers are a bit out of sync. And then, yeah, use your peer support group. If you're unsure of anything as well, like that, if you've got questions about Slack, etc., pop them in your peer support group, and I'm sure people will help. So that's what they're very much there for.
Yeah, that's brilliant, thank you. And I hadn't used the tannoy and noticed that either. So where is the information about the revision sessions?
So the revision sessions, I believe, Elliot may be able to correct me, is that in the tannoy? I think.
Either way, we'll get the meeting invites out first thing tomorrow. So obviously they're optional. If you're coming along, say yes, but if you're not, feel free to ignore.
It might also be, yeah, and it might be worth, I don't know, Elliot, it might be an idea just to, do you want to get people just to message you just to indicate whether they're planning to come along to those sessions, just so we've got an idea of numbers, something like that, just to or as I say, maybe if you just send out the calendar invite, but just make sure you sort of confirm if you are coming. It'd just be helpful to know what sort of numbers we'll have for the various sessions. I think that would be useful. Yeah, cool. So yeah, it should be, so the message about splitting off and doing that is in the tannoy. And Elliot will send out the calendar invites tomorrow, and we can put a message in the tannoy when that's done as well. So yeah, tannoy is the good place to go for here's what's happening. Sometimes it might be quiet for a while, sometimes you might get a flurry of messages. There's always worth just if there's one channel to catch up with stuff, that's the one. Just make sure you haven't missed anything important. Okay, any other questions or anything people want to flag up? No. Okay, well, so this is by no means your only opportunity to do it, so please do message us. We'd encourage you as well. As I said, there's no such thing as silly questions, so do try and I hope you feel comfortable to post either in ideally one of the public channels, or at least in your peer support group channel, because the question you have may well be a question that other people have. There's 100 of you here, more than 100 actually, and so it's worth posting that question, because other people may be able to help as well, and sometimes some of the issues you've got may be better solved by some of your peers who are on a different operating system and may have run into some problem that we haven't got, and other people may have that problem as well, and it helps to solve it for them too. Okay, we'll close off there, and look forward to seeing you next week when we're going to be talking about discrete event simulation, and you're going to start building some actual models with your new Python skills. So we look forward to that. See you then.
Thank you.
Thank you, Dan.
Bye.
Thanks, Dan.
Thanks all. Bye.
Cheers.
Bye.